It's time to spin up a new project for our identity microservice. Just like we did with our inventory microservice, we won't create the new project from scratch, but instead we will use the started project files I have attached to this lesson in the play.identity.start zip file, just under this video. Please download the zip file and extract it into a location in your box. So right here, I have already downloaded that zip file, is right here. So I am going to go ahead and right click and extract all the contents. Right here, I'll just say extract. And I have my new play.identity.start folder right here. So I'll go ahead and delete the zip file. And I'll rename play.identity.start into just play.identity. And this play.identity folder now becomes the location for our identity microservice. Okay, so I'll minimize this. And now here I am in a new instance of Visual Studio Code, where, by the way, I have hidden a few elements of Visual Studio Code just to give more clarity to the code that we're going to be working on. So at this point, we're going to go ahead and open that new folder that we just created. So I'll click on Open Folder right here. And then I'll go into the projects and I'll select my play.identity directory and I'll select folder. So this opens Visual Studio Code in the context of the play.identity folder. Right away, we're going to see that the C# extension wants to restore dependencies. So we'll say yes, restore. And now let me close this. And then what is the difference between this and the other microservices? Again, there's no difference. It's the same kind of a starter template. The main difference here, of course, is that, we have a different namespace. This time it's going to be play.identity.service. But also in properties, under properties in launch.json, you're going to notice that we have, again, new ports. And you can see that the new ports are going to be 5003 for HTTPS and 5002 for HTTP. Okay, those are the ports that we have designed for this identity microservice. Now let me close this. And so what we want to do now is to, instead of coming up with any sort of UI for registration or login for our users, we're going to take advantage of the code generation capabilities of the .NET SDK, and we'll let the SDK generate that UI for us. We don't have to generate it manually. So in order to do that, the first thing that we have to do is to introduce a few NuGet packages. So let me go ahead and open up my terminal. So I'll do Ctrl-J and I'll go into terminal. Now perhaps I'll collapse this for a moment. And here we're going to add a few NuGet packages and a tool. The first thing that we're going to do is install a tool via the .NET tool command, .NET tool install. And we're going to do it globally, -G, and the name of the tool is .NET ASP.NET Code Generator. And then for this tool and the packages that we're going to install, it is very important that you use the correct version of the tool according to the SDK that you're going to be using. In our case, we're using .NET 7. And so let's make sure we specify that version over here. So we will say version 7.0.0 is the corresponding one for .NET 7. So I'll hit enter. And that went ahead and installed this tool globally so that I can use it in any project that I want in my machine. Okay, the next thing that we have to do is to install 4 NuGet packages that will enable code generation for the ASP.NET Core Identity UI. So to do that, I'll go into src play.identity.service. And then let's install those packages. First package is going to be .NET add package, Microsoft.Visual Studio, .web, .code generation, .design. And again, let's make sure we use version 7.0.0. Hit enter. So that package is installed. Let me clean this. The next package is called, and I'll just try to reuse a little bit of this command line. It is called, so let me remove this, Microsoft.ASP.NET Core.Identity.UI. Say UI. Again, version 7.0.0. So I'll hit enter. Okay, let's clean this. Next package is called, again, let me reuse a little bit of this, Microsoft.Entity Framework Core design. Let's not get confused here. We're not going to be using Entity Framework or even SQL Server as part of this program here, but we do need this NuGet package and the next one so that we can generate the UI that we need to generate. After we generate that UI, we're going to remove these NuGet packages, right? So it's just a temporal thing to be able to do the code generation. So Microsoft.Entity Framework Core, .design. So I'll hit enter. And then clean this. And finally, we're going to be doing Microsoft.Entity Framework Core .SQL Server. All right, hit enter. So that is done. And if everything went properly, and if we do Control P, and if we go into our play.identity, by the way, I just did Ctrl+Shift+P, and then I can start typing to look for the name of a file. In this case, I'm looking for play.identity.service.csproc. What I'm going to show you is that now we have all those references added into the project, right? So they're showing up right here, and they're showing up also over here. All of that has been properly added. Okay, so let's close this, and then let me go back, Ctrl+J into my terminal. What we can do now is actually use the code generation to generate the files that we need. So to do that, we're going to do .NET ASP.NET code generator. And here you have to define what kind of code generation you want to execute. In our case, we want to generate files for identity. So we will just say identity. And then here the interesting thing is that you have two options. You can this framework can use all the files that are built into the .NET runtime and keep the files inside so you don't have to see them at all. Or you can ask it to pull out some of the files that you do want to modify so that they're combined with the files that are already built into the ASP.NET Core runtime. It's a nice capability that allows you to customize the files that you want to customize while keeping all the other files inside the framework and outside of your project. So in our case, since we do need to customize the logic for registration, we're going to ask the tool, bring in the files for registration. So we're just going to say files, and then we will say account.register. So I'll hit enter, and this should go ahead and it's going to build our project and make sure that everything is built in properly, and then it will go ahead and perform the code generation. And that just completed. So let's now close this terminal and let's go back into our Explorer. Ctrl+Shift+E to go back to Explorer. And then let me expand this a little bit. And you're going to notice that there are a bunch of new directories and files in our structure. So right away, you can see that there's an areas section here, okay, where the important thing really is the pages that it has generated. And under account, you can see that now we have a page for registration. That's the one page that we took out of the ASP.NET Core binaries and into our own project so that we can modify them later. And we'll take a look at those files later. But for now, there are more files here than what we need. And some of those files are actually this data and this identity hosting startup. We don't need those at all for our project. So we're going to just right click and delete that. So data goes away and identity hosting startup also goes away. What else we have here? We also have a pages directory which has some shared layout and imports as part of the Razor Pages framework. Use it, of course, some sort of layout to the pages that you're going to see for login and for registration. But we're not going to be touching those really much across this course. The other thing is www.root, which adds some CSS, some JavaScript files, because these are Razor Pages. They need some sort of styles, right, to look pretty, basically. And lastly, there's this scaffolding readme.txt that just tells you that, yeah, I mean, the support for ASP.NET Core Identity, which is the framework we're going to be using for identity, has been added. Now, one thing that we can do also at this point is just go back into our project file, and we can remove the Entity Framework package references, because like I said, we don't need anything from Entity Framework really here. Moving on. And so we're just going to remove these two package references, Microsoft Entity Framework Core.design and Microsoft Entity Framework Core.SQL Server. So I'm going to remove those two. We don't need them. We just stick with these three references for now. So now let's make sure, so I'll close this, and let's make sure everything is building. So I'm just going to do Ctrl+Shift+V, my keyboard, and this should build successfully. Everything is building just fine, no errors. And at this point, we have a new identity microservice that is already integrated with a few basic ASP.NET Core identity building blocks, most of it generated by the .NET CLI and the ASP.NET Code Generator. In the next lesson, we will expand our ASP.NET Core identity integration by using MongoDB and its backend store, and we will enable both registering new users and letting them log into the system. By default, ASP.NET Core Identity uses Entity Framework Core and SQL Server as its backend store. However, since our existing microservices are already using MongoDB, it's not a bad idea to use the same database in our identity microservice. Let's see how to enable this. So here I am in Visual Studio Code once again, and I have opened my terminal into the play.identity.service directory. And what I'm going to do now is to add a couple of NuGet packages that we're going to need to enable the MongoDB integration. So let's add the first package, .NET add package ASP.NET Core .identity.MongoDB Core. This is the package that enables having a series of stores. It's called stores classes that can integrate with ASP.NET Core Identity to enable MongoDB as a backend store. It's a public open source project that you can find in the web. The next one is just going to be our play.common library. .NET add package play.common. Okay. And as you know, we've been creating this library so far so that we can reuse a bunch of components from that one. And in this case, we're going to be using the service settings class that we have in that library to specify the name for our microservice and how to name the database that's going to be used in this microservice. Now that we have that, I'm going to close this terminal, and I'm going to now define the entity classes that are going to define the users and the roles in our identity microservice database. So to do that, the first thing is going to be add a new entities directory. So I'm going to right click and at the root here, new folder. It's going to be entities. And in this folder, I'm going to create a new file. It's going to be named applicationuser.cs. Let's give it a namespace. It's going to be play.identity.service.entities. Okay, so let's declare the class. So public class application user. And then this class has to inherit from the Mongo identity user class. That has to be of type. In this case, it's going to be GUID, because the ID of our users is going to be of type GUID. But to use this class, we have to import namespace from that NuGet package we installed a moment ago. So to do that, we can do control dot, and then we can import the ASP.NET Core Identity MongoDB Core Models namespace. Similarly, for the GUID class, we can do control dot, and then we can import the system namespace. So this application user represents a user in the system. And one customization that we're going to bring in here is the fact that we want to allow the user to specify how much GIL or how much money it has in his bag, so he can use it later to buy items from the catalog of items. So to do that, we're going to define a property here. It's going to be prop decimal GIL. So that's how much GIL the user counts with. And one more thing that we might want to do to this class is to specify what is going to be the name of the MongoDB collection that's going to be generated into the identity database. Just so that we don't end up with a collection named application users, but instead, for instance, we can give it the name of just users. So to do that, it is really just as easy as specifying an attribute here. So we can say collection name. And let's see if we're missing a namespace. Yes, let's use MongoDB generic repository.attributes. And the collection name we're going to give to this class is going to be users. That way, a users collection is going to be created into the database. Now, just like we did this, let's create another class to represent the roles, the user roles in the system. So right click on entities, new file. Let's name it application role. .cs. Let's give it a namespace. Play.identity service entities. And then let's declare the class application role. And in this case, the class needs to inherit from Mongo identity role, again of type GUID. And again, we have to import the right namespaces. Let's do that. And that's pretty much going to be it for the class. We don't need to add a body in this case, but we want to still specify or decorate this class with the collection name attribute. So collection name, and I'm going to import again that namespace, just so that we can name the collection as just roles, as opposed to application role, which is what you would get if you didn't specify the roles attribute. Now keep in mind that you can keep extending both the roles class and the users class with as many properties as you need in your system. This is really up to you, and all of those are going to end up in the database. So for our purposes, this is really all we need at this point. And now that we have these two classes ready, it is time to make use of them where it makes sense. And the first place where we're going to use them is in pages, shared, and login partial.cs HTML. Now this file here is the Razor page for our login experience. And really the only thing that we want to do here is to make sure we stop using the identity user class here, which is built in as part of the ASP.NET Core identity framework. And we want to switch it to use our brand new application user class. So what I'm going to do is just select identity user. I'll do a Control H, and let's replace it with application user. Okay, so replace and replace. Okay, now for this to actually work, we also have to import the correct namespace, just like we do in our normal C# files. So I'll do using play.identity.service.entities. All right. So with this, login partial will make use of the correct application user class. Now let's close this one and let's go now into areas, account, and register.cs HTML. And I'm going to collapse this for a moment. And this file here is another file based on the Razor Pages framework that represents the C# code that is behind our registration experience. And if we scroll down here, you're going to see that this is a class named register model that inherits from page model, okay, which is the abstract class that represents a page in the Razor Pages model. And in this class, we're making use of a few objects here that we know as identity managers. So these are different objects that can be used to interact in one way or another with the ASP.NET Core identity framework. So we declared all those plus a few other helper objects here, and we are injecting instances for all of those in the register model constructor. Now, if you keep scrolling down, we'll see that we have a property here called input, right, of type input model, and this is the property that will have all the inputs that the user has entered in the registration page. And we're going to see this input model in a second down there. And then also we have a couple of output properties that we're not going to be touching right now. But if we keep going down, we're going to see that here is the actual input model. And the input model has our email, our password, and the confirmed password that the user will enter in the registration page. Now here we also have a couple of methods like onGetAsync, which is used when this page is being retrieved back into the client, right, into the browser. And we also have onPostAsync, which is a method that is being invoked when the register page is sent into the server, right? Now, the first thing that we're going to do in this page is make sure that we also make use of this application user class. So let me scroll up. And as you can see, all of our identity managers currently are using the identity user class. So let's just make sure we change that. So I'll do Control H, and then replace again identity user with application user. And let's just do use this button here for replacing everything. So replace all right there. Okay. And we also need a namespace. So I'll select application user right here. I'll do control dot, and then I'll do using play.identity.service.entities. All right, and for some reason that didn't work. So let's just do the import manually this time. So I'm going to go up here and I'll say using play.identity.service.entities. And now we have that, we're going to go down into our onPostAsync method. And like I said, this is the method that's invoked when the page is sent back into the server, right, to perform the registration. And what we want to do is to modify this user here, this application user, so that it has the initial starting yield that we're going to be assigning to every new user. All right. And so for that starting yield, what we're going to do is first, let's actually go back to the top and let's declare a constant at the very top here. So over here, we'll declare private const decimal starting yield, which is going to be, let's say 100, right? So every user will start with 100 yield. So let's now go down into onPostAsync right here. And what we're going to do, like I said, just after creating this user object, we're going to add one more line and we will just say user.yield equals starting yield. That will make it so that when we reach this other line down here and the user is sent down into a ASP.NET Core identity, it will be created into the identity database using that yield that we have specified. Okay, and that's really all we have to do in these Razor pages. And what we want to do now is go and add the required configuration into our appsettings.json file. So I'll do Ctrl+Shift+E to show my Explorer, and then I'll go down into our appsettings.json file, this one over here. And the first thing is going to be getting rid of these connection strings setting here that we don't need. That will be for entity framework, we don't need that. And then, just like we did with the other microservices, we're going to declare service settings. And here we have to declare the service name. So in this case, service name is going to be identity. The next thing is going to be our MongoDB settings so that we can tell how to connect to MongoDB. So MongoDB settings. And so we need a host, which again is just going to be localhost. And we need a port, which as usual is just 27017, the default port that MongoDB uses. And now that we have that, it is time to go to startup to actually wire up all of these things to make sure that everything is constructed properly on boot. So I'll go to the startup file on the left side here. And perhaps this time we'll just collapse this again. Scroll down into our configure services method. And here we're going to do a few things. First, we need to configure MongoDB, the MongoDB driver, so that it serializes all of our GUIDs as strings. So this setting that we're going to specify here has already been configured if we were using MongoDB directly, as we've been doing in other microservices. But in this case, remember that we are using MongoDB as an integration point with ASP.NET Core Identity. So we don't talk directly to MongoDB ourselves. So there are some things that we may have to do a bit more manually than before, but it's not really a lot. So let's do bison serializer that register serializer. And let's see if we need something to import. Yep, so using MongoDB.bison.serialization, register serializer, and then we'll do new GUID serializer, import missing namespace, and then we will do bison type, control dot, using MongoDB.bison.string. So with that, all GUIDs are stored as strings in the database. The next thing that we're going to do is to capture the values of our service settings configuration and our MongoDB settings configurations that we just put in appsettings.json. So to do that, let's do var service settings equals, we'll use our configuration class as usual, get section, and it's going to be, the section has to be the name of service settings, which we may need to import here. Yep, using play.common.settings comes from our play.common NuGet package. And then we'll convert that via the get method. We'll convert that into a service settings instance. Okay, so that's how we can read service settings. And then let's also read our MongoDB settings. So MongoDB settings, same thing, but now the name is MongoDB settings. And now comes the most interesting part so far, because here's where we're going to wire up the ASP.NET Core identity pieces into our startup. So we're going to be using a method that sets off all the default configuration of ASP.NET Core identity for us, so that we don't have to really write a lot of code for this. So to do that, we can do services.addDefault identity, and then you have to specify the type of your user, the entity, the user entity that we'll be using with our database and with ASP.NET Core identity. And as you know, that's going to be application user, for which we may need to import a namespace again. Yep, there it is, import namespace. So just by doing this, all the different UI components from ASP.NET Core identity will just work in our identity microservice. You'll see in a moment how that works, plus a few other things. But we need to do more. So we don't just have users, we also have to specify roles. So for our roles, we'll say that add roles, and here's where we're going to specify application role. And next is where we have to actually configure ASP.NET Core identity to use MongoDB. So to do that, what we're going to do is just say add MongoDB stores, and then we specify our user class, application user, and our role class, application role, and then the type that we're using for the identity of our users, which is good. Okay, let's open a constructor here. And here we have to specify two parameters, which are going to be the connection string to MongoDB and the name of the database. So for the connection string, we can say now MongoDB settings dot connection string, and for the database we can say service settings dot service name. Okay, so with these few lines, we have configured ASP.NET Core identity and we have connected it to our MongoDB database. Now there are a couple of more pieces of configuration to do here in order to make this work properly. Since we are not now bringing UI components into what was otherwise just a web API project, we need to add a few lines in the configure method. Let's scroll down into configure, and let's add a line somewhere around here saying app.use static files. So this is so that all those static files that we saw a moment ago in the Explorer can be used in this application. And also we have to go here and in the use endpoints call here, we have to configure endpoints to also be able to use razor pages. So endpoints dot map razor pages. And this is because a web API project normally has nothing to do with razor pages, but in our case, we are extending it a little bit so that we can show the razor pages that come from ASP.NET Core identity. So now we are almost ready to see our service running in action. But one thing that we should verify before doing that is to make sure that we have our Docker containers up and running, specifically the container for MongoDB, of course. So to do that, I'm going to open up my terminal here by doing Ctrl-J. And I'm just going to do docker ps to see if I have any container running right now. So from this, I can tell that there's no containers running. So I'm missing my MongoDB container. So to get that up and running, what I'm going to do is to go back to my play.infra directory. So let me go back up into projects, and now I'll go into play.infra, and here's where we have our Docker Compose file. So to start our infrastructure services, I just have to do docker compose up, and then -d for the dash mode. And that's going to go ahead and start our containers, both MongoDB and RabbitMQ in this case. So now that I did that, let me go back to where we were. So play that identity, src, identity service, and then I'll just do .NET run, and that's going to start up our identity microservice for the first time. So there it is, up and running. And now we can go ahead and try to register a user in the system. So to do that, let me actually open a browser this time. And we know that our service is living in localhost 5003. And the registration page is actually in this location, identity, account, register. So if you go to that location, you're going to see this page, which is provided by the ASP.NET Core Identity built-in UI components. So now that you're here, you can go ahead and create a user. So for instance, I'm just going to create really a fake user with some fake email like player1@play.com. And then I'll type a password. And then before we actually create this user, notice that there's built-in validation in this page already. So for instance, if I don't use a proper email, like something like this validation is going to kick in right away, right? And if my passwords perhaps don't match, that's going to also kick in some validation. So this page by itself is already very useful for our registration purposes. So I'll go ahead and click register. And the user should have been registered by now. And of course, we're seeing this kind of unexpected page, but this is because we are not really in a location where we can display a home page, right? This is not really a web portal. We just happen to be navigating into the registration page to create a user because it is convenient, but we don't have a portal by any means right now where users can go in and have a home page and then navigate. But the user should have been created. So let's take a look at VS Code, and let's take a look at the database and see how that's looking. So I'm going to collapse this terminal, and I'm going to bring in via Ctrl-Shift-P, I'm going to bring in the activity bar on the left side, and then I'm going to show via this ... our MongoDB database. So minimize this and that, expand this. And notice that now, next to our catalog and inventory databases, we also have an identity database now. And that database now has a users collection, and that collection has one document, which is going to be our user. As you can see, player1@play.com, and you're going to see that it has a bunch of other attributes that are coming in by default from ASP.NET Core Identity and the MongoDB integration that we have enabled. But also notice that at the very end, our property is also included. So this user has a default amount of 100 GIL already defined for himself. And now that we have this user could potentially also log in into the system. So if you go back to the page, let me go back to, still back. We're back in the registration page, but we can also now click on login over here, login. And here's where the user could just log in. So I'll do player1@play.com, the password, and then I'll do login, and the user would have logged in. Of course, we can't verify this by any means right now, because like I said, there's no home page, but the login functionality is in place. Okay, I'll close this. And so at this point, we have a way to register and log in our users, and we have a database populated with users right now. So in the next lesson, we are going to add a proper REST API to manage users so that other components in the system can actually interact with our users database. So far, we can register and sign in users into our identity microservice via the ASP.NET Core Identity default UI pages. However, we should also provide a REST API that other parts of our Play economy system can later use to interact with our users database. So let's add a users REST API. I'll start by going to the root of our play.identity.service directory. So I'll just right click and I'll add a new file that we're going to call dtos.cs. And in this one, let's add the right namespace. So it's going to be play.identity.service.dtos. We're going to define two DTOs here. The DTO to retrieve or to get users from the database, and the DTO to update the information about a user. We are not going to define a DTO to create a user into the database because that is already covered by user registration in the UI page for registration. So let's define our first DTO. It's going to be public record user DTO. It's going to have an ID, and let's import a missing namespace using system, a username, and email, the amount of GIL assigned to the user, and a created date, the date that when the user was created. Okay, so that's the DTO used to return users in our get REST APIs. Next, let's define public record update user DTO. So this is going to have just an email and the amount of GIL. So these are the only two things that we're going to allow updating in the user, their email and the amount of GIL. Nothing else is going to be modified. But now, since this is a DTO for performing updates, we probably want to have a little bit of validations right away before accepting values via this DTO. So we're going to, for the email, of course, we're going to say that this is required, and let's import our system component model data annotations namespace. And since it's actually an email, we can also actually take advantage of the validator for email addresses. So here we can say email address, and that will make sure that whichever value comes in there, it has to be an email address. No other kind of a string is going to be allowed. And then for the GIL, we're going to say that there's going to be an allowed range of values. So we're going to say range. And that range is going to go from 0 to, let's say, 1 million. So 1 million is the maximum amount of GIL that can be assigned to any of our users. Okay, so that covers the two DTOs that we're going to be using. And just like we have done in other microservices, we're going to create also an extensions class that can map from our application user entity into our user DTO for the purpose of using them in our get REST API operations. So I'm going to right click over here, play identity service again, right click, new file, and let's name it extensions.cs. And let's give it a namespace. It's going to be play.identity.service. And let's define the class, static class extensions. And the method is going to be public static user DTO. Remember that all extension methods should live in a static class and they should be static. So the method is going to return a user DTO, and let's call it as DTO. We may need to import, let's import a missing namespace. And this is going to be extending our application user class. Let's name it user. And let's import a missing namespace again. And let's open and close braces. So remember, we use extension methods here so that anytime we have an application user, we can easily transform it into a user DTO, specifically for the purposes of returning this user in our REST API. So for that transformation, we can just do return new user DTO. Now we will say user.id, user.username, user.email, user.gil, and user.createdOn. And again, perhaps I'll do multiple lines so that we can see better what's going on here. There. So that's all we have to do for the extension method. So now for the actual interesting part, which is the creation of this user controller. So let's go to our controllers folder where we have nothing right now. And I'll right click, I'll say new file. And let's name it users controller.cs. And at this point, I'll go ahead and just collapse this pane here so we have more space to see. Let's declare a namespace. So namespace play.identity .service.controllers. Let's declare our class, public class users controller, which has to inherit, as we know by now, from controller base, which makes it an API controller. And also it has to be decorated with the API controller attribute so that we get some built-in by default behaviors, nice behaviors for validations specifically, and a few other behaviors for error checking. And also let's define a route, a default route for this controller. And that route is going to be just users. And so the way that we're going to interact with our users database is not by talking directly to that database via the MongoDB driver, but instead we're going to be using the user manager, which is the class that ASP.NET Core Identity provides us so that we can interact with users without having to know what database has been configured in the backend. So let's go ahead and declare a private variable to hold on an instance of this user manager. So private read-only user manager of type application user manager. So let's import missing namespaces there and here. And then let's define a constructor for this class so we can receive that instance. So public users controller user manager of type application user manager. So as you can see, we are doing dependency injection of an instance of the user manager that's going to be provided by ASP.NET Core Identity, and we're just going to assign that to our local user manager instance. So now we can start defining our actual REST API. And as usual, we'll get started with the get method. So let's define the get method that we can use to retrieve all the users in the database. So let's scroll down a little bit here. And let's define public action result of type IEnumerable of type user DTO get. So just get like that. And so let's make sure we import the right namespaces. And this is user DTO there. And let's add the correct attribute for the verb. So this is going to be an HTTP get. Okay, let's go down a little bit. And so to retrieve the users from the database, we can use the user manager in a very straightforward way. So we can do var users equals user manager dot users, and then I'll do to list. Let's import system.link for this call, and then we'll do the transformation into our DTOs. So I'll do select user, transform that user into a DTO via our asDTO extension method. Yep. So with that, we have our users, and then we can just say return an OK result with users. Okay, so that's all we have to do for the users get operation. Let's now implement an operation to retrieve information of one specific user. So in that case, we're going to define public async task of action result of user DTO get by ID async. It's going to be the name. It's going to receive a GUID ID. Okay. Again, let's import missing namespaces. We need tasks. And I think we need system here. Yep, using system. And let's also decorate this with the right verb, which again is HTTP GET. But we're also going to be needing to define a template for this method because we have to receive an ID here in order to identify the user we're going to return. So in this case, we need to receive an ID in the route. So the end of the route has to be ID. So basically something like /users and then /123. So some ID, right? That's going to be the ID. And so let's go ahead into the body. And again, to implement this, we can make use of the user manager. So we'll say var user equals await user manager that find by ID async. And then we'll do just ID, but this expects a string. So we will do toString. Going down. And so two things can happen here. Either we find the user and we can return it, or we don't find it, and that's going to be just a null value. So let's first check for that null value. So if user is null, we will just say not found. Return not found. Can't find the user. Otherwise, we can return user converted as DTO via our as DTO extension method. Okay, so that's it for the get operations. Now let's work on our update operation. So the one that we can use to modify an existing user. So this is going to be, again, public async, task of action result, put async. This one has to receive the ID of the user to be modified, and our update user DTO, which contains the payload of the modified user. Let's decorate this properly with the HTTP put verb and a template for also ID. So same route as we got over here. Users 123 is the route that you will be using for the put, right? But in this case with a body. So in order to do an update operation, the first thing that we have to do is, of course, try to find the user. And so to do that, that's going to be actually very similar to what we did for get. So I'm just going to do the same first few lines as in get. I'm going to copy that over here. So that way we can find the user. If we cannot find it, not found, no issues there. And then if we can find it, it's time to update the details. So in this case, we want to update user.email. It's going to be user.dto.email. But then we have a convention here already established by ASP.NET Core Identity where the username of the user is exactly the same as the email. So we will follow that convention. So we will say that user.username is user.dto.email. So that's how users are created when you register them, same username as email. So we will just follow that for an update. And finally, user.jill equals user.dto.jill. Then we'll go ahead and say, oh wait, user manager that update async user. And finally, as with any put method, we can just say return no content. So that's the update operation. And now let's go ahead and do the delete operation. Okay, so for this one, let's declare public async task action result, delete async, and we are going to receive only the GUID this time. So GUID ID, scroll down, Again, let's decorate this with the right verb, HTTP delete. And the template again is going to be the ID. So just like before, we said, we're going to have a route like /users/123, just like that here, just for reference. And just like before, we can find that user first. So again, same 3 lines. Can do that here. Find the user. If we don't find it, it is a not found user, of course. But if we can find it, then we will say await user manager dot delete async. We send the user, and then we can return no content. Okay, so with that we have our REST API all ready to go. So it is time to try it out. So I'm going to go ahead and do Ctrl-J to open my terminal, and I'm just going to do .NET run in the play.identity.service directory. So .NET run starts web server. And now what I'd like to do is to grab the swagger.json OpenAPI specification to import it into Postman. So to do that, I'll open a browser. And then I'll go to localhost 5003, and then I'll go to Swagger, which is built in into any .NET 5 project, ASP.NET Core project. And you can see we have our REST API ready to go there, but we're not going to be playing with it over here. We are actually going to be clicking on Swagger v1 swagger.json, and we're going to copy this URL. Now let's open up Postman. And here, as you remember, we do have our collections for the catalog and the inventory microservice. So it is time to import the one for our users REST API in the identity microservice. So I'll just click on import, and I'll click on link. I'll paste our swagger.json file here, the URL, continue, and then I'll just say import. Okay, and so with that, we can start trying out all these APIs. So let's go to play.identity.service. We have our users section here, and then let's try get users. But of course, before doing that, we have to modify over here the play identity service collection. We'll click on ... we'll do edit, and we'll go to variables. Okay, let me close this section here. So here, remember, we have to specify the base URL that Postman is going to be using when calling the methods in this REST API. So in this case, we know that the URL is going to be https localhost 5003. We'll do that for initial value and for current value. Okay, so I'll close that. I'll save changes. And now we can go to our get users API, where base URL is https localhost 5003, and I'll just hit send. And as you can see down here, we have our one user is being returned. So the integration with ASP.NET Core and MongoDB seems to be working just fine for the REST API. Let's also test our other methods. For instance, let's try to get a user by ID. So let's grab this ID. I'll do the get users by ID method here. I'll just paste the ID right there, hit send, and yep, that is working properly. Let's also try our put operation, in which we're going to paste ID once again, but now we have to specify a body, right? So let's grab the details, the current details from the user, like the email and Jill, from this tab to this tab. And what we're going to do, we're not going to change the email, but perhaps we can change the amount of Jill. So let's say that instead of 100, he can have 200 Jill at this point. And with that, let's hit send. We got 204 no content, which is expected. And if we do a get again for this user, send, we can tell that yes, the Jill was updated to 200. And finally, we can go ahead and test the delete API. Let me just copy the user ID once again. Delete API. We'll paste the user ID right there, and we'll hit send. At this point, the user should not exist anymore. If we try to do a get for that user, let's see what happens. Yeah, photo 4 not found. The user has been removed. So yeah, it seems to be working just fine. And with that, our integration with ASP.NET Core Identity is mostly complete. That's the end of this module, and in the next module, we will learn about the multiple patterns and techniques that you can use today to secure your microservices. In this module, you will learn about the modern approach to microservices security, the tools and techniques you can use today to protect your microservices, and how to properly integrate them into our identity microservice. By the end of this module, you will have a solid understanding of the following: why a microservices-based system needs authentication, what is and how token-based security works, what is OAuth 2 and the participants and steps of the authorization code flow, what is OpenID Connect and how it complements OAuth 2, what is Identity Server and how it relates to OAuth 2 and OpenID Connect, and how to turn our existing identity microservice into an authorization server. Let's get started. In this lesson, you will learn about the need to introduce identity-related components to your microservices-based application, the dangers of not doing this correctly, and the modern approach to securing your services. Let's go once again through one of the scenarios enabled up to this point. John, one of our players, would like to see the items in his inventory back. He would request his inventory via his preferred client, and this one in turn would send a GET request to the inventory microservice, asking for all items associated to the specified user ID. Normally, the inventory microservice would just return the items. However, our service should probably start asking a few questions before handing them over. For instance, inventory may want to ask, "Who are you?" or "Are you allowed to talk to me?" Since it should probably not just hand over its precious data to anybody that asks for it. But even if the request is allowed to come in, another important question arises. Do you have access to John's inventory back? Think about it. Inventory doesn't really know that the caller is John. It could be any other player trying to retrieve John's inventory, which by all means should not be allowed. Only if our microservice can answer these questions and can confirm that the caller has access to the items, it would query them from this database and return them. In summary, we need to establish the identity of the caller. The good thing is that we do have an identity microservice by now, so we should be able to enable authentication in our system. That is, we should be able to confirm that the caller is allowed to retrieve the items for the specified user. For instance, the client could be modified to present a sign-in screen to collect the email and password of the user, and then send them in the request to the inventory microservice. Inventory would then ask identity to confirm the credentials are valid, and probably also ask to return additional info about the user, like its user ID, to correlate with inventory database. If all looks correct, inventory would be ready to return the data to the caller. We would also update our other microservices like Catalog to receive the credentials and do the corresponding checks with identity. The problem with this approach is that we will be sending the user's credentials on every single request to each of our microservices, which presents a few concerns. If SSL is not enabled, which of course should not be the case, an attacker with a package sniffer could easily grab the credentials. Even if SSL is enabled, tools like Fiddler, capable of decrypting the URLs, could have been installed in the user's machine, assuming the user provided consent for it. The URLs would likely get logged on each microservice, and the logs might not be secured properly. The size of each request will be bigger than it needs to be, and there are limits to request URLs. The client would need to ask for credentials every time, or perhaps would keep them in its local cache, which is just as bad. And let's not forget that we might overwhelm our identity microservice with potentially hundreds of checks on every request from each of our microservices, which will of course also slow down the overall system unnecessarily. There's probably a better way to authenticate our users. As a side note, I just wanted to call out a bad practice of some websites that you might be familiar with. Have you ever tried using one of these sites that asks you for your bank account credentials so it can help you manage your finances? Think about what these websites are doing. They would even assure you that your data is very safe since your login username and passwords are stored securely in a separate database using multi-layer hardware and software encryption. Even with their best intentions, this is definitely a bad idea because nobody other than your bank who owns your credentials should have a copy of them. You really don't know what this third party is planning to do with your credentials, how safely it is storing them, and also what exactly you're allowing them to do with your bank account. Presumably, this is read-only access to your account, but how can you be sure? We won't be dealing with external websites in this course, but the appropriate authentication and authorization patterns you will learn next still apply for any scenarios like this. What is then the right way for our client to request access to John's inventory back? The ideal and modern approach is called token-based security, and it works like this. When John wants to get his inventory back, the client first requests authorization from an authorization server, which in our case would be our identity microservice. It is this microservice, not the client, that will then present John with the sign-in form where he will enter his username and password. Once John submits this form, his credentials will be sent to the identity microservice, not to the inventory microservice for validation. Once identity has verified the credentials, it generates a signed authorization token and sends it back to the client. The client can then use this authorization token to try to access John's inventory back in the inventory microservice. If inventory can verify that this token presents the required authorization, it will go ahead and return the items to the client. Notice that with token-based security, the credentials are sent only once from the form presented by the authorization server and not on every subsequent request. There is more going on here before generating the token, but we will look into these details in the next lesson. The generated token represents consent from the user, and it includes information about how to verify the token, since it includes details about how it was signed, where it came from, since only tokens generated by our authorization server should be allowed, where it can be used, because it should be valid for use only by our microservices, who is authorized by the token, since it can include many details about John in this case, including his authorization roles, what can be done with the token, because a token may grant access only to some microservices, or even to specific actions within a microservice, and much more. Now the question is, how to generate this token and how to do it in a standard way so that we follow all the best security practices while not having to spend a lot of time writing code to get things right? Luckily, there are already well-known protocols and standards that we can use for this. In the next lesson, we will learn about OAuth 2, the de facto standard for authorization these days. In this lesson, we will learn about the OAuth 2 protocol, how it works, and why it should become the basis of your microservices security strategy. Let's start with the standard definition of OAuth 2. OAuth 2 is the industry standard protocol for authorization, allowing a website or application to access resources hosted by other web apps on behalf of a user. In essence, it is a security standard where you give one application permission to access your data in another application. The framework that describes OAuth 2 was released in 2012 and as of today has been adopted by dozens of service providers of all sizes. Let's see how it works. There are multiple authorization flows supported by OAuth 2, but here we will focus only in the recommended flow for single-page applications or SPAs and native clients, which are the ones our microservices will integrate with during this course. Let's first understand which are the participants in an OAuth 2 authorization flow. The resource owner is the person or entity that owns a resource, like John in our case, who owns his inventory back. The resource server is the server or service that hosts the protected resources owned by the resource owner. An example here is our inventory microservice, which owns the database that contains the inventory items. The client is the application that wants access to perform actions on protected resources on behalf of the resource owner. This would be our game client, our web front end, and even the Postman app when doing local testing. And the authorization server is the server capable of authorizing the client to get access to the protected resources after authenticating the resource owner. This is our identity microservice. The flow starts when the resource owner uses the client to initiate an authorization request to perform some action, for instance, to retrieve John's inventory back. The client generates a code verifier, which is a hard-to-guess value that will be used later in the flow. The client then generates a code challenge, which is an encoded hash value derived from the code verifier, and sends it as part of the authorization request to the authorization server. The authorization server presents a sign-in page where the resource owner can authenticate. After authentication, the authorization server might optionally also present an additional page where the resource owner can provide explicit consent to which actions can be performed on the resources he owns. After this, the authorization server stores the code challenge for future verification and generates an authorization code which it sends back to the client. This authorization code is valid only for a short amount of time, ideally no more than 10 minutes, and is only good for one use. The client can then use the received authorization code plus the code verifier it had created at the start of the flow to request an authorization token. The authorization server verifies this request by generating the code challenge itself out of the received code verifier and comparing it with the code challenge it had already stored. If this doesn't match, then the request likely comes from a malicious application and an error is returned to the client. If all looks good, the authorization server verifies the received authorization code and generates an access token. The client can now use this access token to send a request to the resource server so it can perform the desired action on the protected resources. The resource server validates the received access token, and if all looks good, it executes the requested action and returns the corresponding response. This whole flow is known as the authorization code flow with PKCE, where PKCE means proof key for code exchange. This flow is ideal for public clients like single-page applications or SPAs and native or mobile applications, because there is no need to store a static, hard-coded secret in the client, which could easily be stolen. With no secret, the client can't get an access token right away. It needs to first acquire a valid authorization code only available after the user authenticates and provides consent. And even if a malicious application steals the authorization code, it would not be able to acquire the code verifier, which is dynamic and is only known to our own app. Let's take a closer look at the elements involved in the initial authorization request sent by the client. This is how an authorization request for the authorization code with PKCE flow looks like. Let's understand what each piece means. This is the address of the authorization server, which in this example is running in our local box. This is the endpoint in the authorization server that can be used to request an authorization code. There are many other standard endpoints available in the authorization server, as we'll see in a future lesson. By specifying code in the response type, we are asking the authorization server to respond with an authorization code, assuming successful authentication by the resource owner. The client ID is the unique identifier of the client, which was provided to the authorization server when the client was registered. Scope represents the resource or set of resources and the actions on these resources that the client would like access to. In this example, the client is asking for access to the inventory microservice REST API. The scope could be more granular if you wanted to allow only for read access, read-write access, or perhaps a more custom scope if needed. Redirect URI is the address where the authorization server will redirect the user after successful authentication. Just like the client ID, this URI should have been provided to the authorization server when the client was registered, which prevents phishing attacks. The code challenge is the encoded value derived from the hashed code verifier that the authorization server will store for future verification. And finally, the code challenge method is the method used to hash the code verifier to turn it into the code challenge. Let's now inspect the elements of the access token request, which the client sends to the authorization server after acquiring the authorization code. Again, this is the address of the authorization server, our local box in this example. This is the endpoint in the authorization server that can be used to request an access token. By specifying authorization code in the grant type, we are asking the authorization server to exchange the provided authorization code with an access token that the client can later use to talk to any of our microservices. As mentioned before, client ID is the unique identifier of the client, which was provided to the authorization server when the client was registered. Again, redirect URI is the address where the authorization server will redirect the user after successful authentication. It must match exactly the value used when requesting the authorization code. Code is the authorization code provided by the authorization server via the authorization request. And code verifier is the original code verifier that the client generated before computing and sending the code challenge as part of the authorization request. I think it's good to know the elements of both the authorization request and the access token request, since they help understand the different pieces involved in the OAuth 2 protocol. In the next lesson, we will learn about another important component of the microservices security landscape, called OpenID Connect. In this lesson, we will learn about OpenID Connect, its mechanics, and how it complements the OAuth 2 protocol. What is OpenID Connect? Don't worry, it is not an entire new security protocol to learn. OpenID Connect is just a simple identity layer on top of the OAuth 2 protocol that allows clients to verify the identity of the end user. Notice the emphasis on verified identity. Identity is the one piece that OAuth 2 misses because, think about it, OAuth 2 allows an application to get access to resources on behalf of a user, but the client application never really knows who is that user that provided authorization. Let's understand why this is so important. Let's look at our simplified OAuth 2 flow once again. Just as before, John uses the client application to request authorization to retrieve his inventory back, owned by the inventory microservice. The identity microservice receives this request, authenticates John via the sign-in form, and, after the usual OAuth 2 protocol exchanges we learned about in the previous lesson, it sends back an access token to John's client. Now, imagine that John doesn't use this token in his client app, but instead he shares it with Jane by just pasting it in an email or an instant message. Jane then somehow provides this token to her own copy of the client app and then uses it to request John's inventory back. The inventory microservice will find no issues with the token, so it will gladly return the items in John's inventory to Jane's client. Everything looks good from the point of view of our microservices, but the client app was able to get access to protected resources when it shouldn't. This is because access tokens are not meant for the client app, but only for the protected resources. The client app can't even understand the access tokens. It needs a way to verify that access to the resources was granted to whoever is making use of the app. Let's see how OpenID Connect can help with this problem. Since OpenID Connect is based on OAuth 2, the involved participants are mostly the same, but they receive slightly different names. The end user is the person, and in this case an actual human, that needs to get authenticated. The relying party is the client application that outsources end-user authentication to an OpenID provider. The OpenID provider is the server capable of authenticating the end user and provide claims to a relying party about the user. The flow starts the same way as with the OAuth 2 flow, but a key difference is that in the authentication request, a very specific scope called OpenID is required. This is really the only thing that signals to the OpenID provider that the relying party needs authentication. Other optional standard scopes could also be used here to retrieve additional claims about the end user. Upon receiving this request, the OpenID provider redirects the end user to the sign-in page as usual, optionally asks for consent to specific permissions and then returns an authorization code. And just as before, the relying party then uses the authorization code to request tokens from the OpenID provider. Another big difference here is that the OpenID provider returns not one, but at least two tokens, the access token and the ID token. This additional ID token is what the relying party can then use to verify the identity of the authenticated user. It contains one or more claims about the end user, depending on the requested scopes. A key claim here is the subclaim, which provides the unique identifier of the user. After this, the relying party could either request more information about the end user via the OpenID provider user info endpoint, or it can just use the access token to make requests to any of the resource servers, like inventory in this example. Like I mentioned before, the main benefit of using OpenID Connect on top of OAuth 2 is the fact that the client can now verify the identity of the end user. But there are several other benefits of using this protocol. Scopes in OAuth 2 are very loose, so each service has to define them according to their needs. In OpenID Connect, there is a standard set of scopes you can use to request additional claims about the user, like profile, email, address, and phone. There are several standard claims that the OpenID provider can return upon request, like the required subclaim, which provides the unique identifier of the user, but also many other claims like given name, nickname, email, birth date, and many others. The user info endpoint is a standard endpoint in the OpenID provider that can be used to retrieve more information about the end user that might not be available as part of the ID token. More than a specific OpenID Connect offering, single sign-on is a side benefit since a single OpenID provider can be used to authenticate end users coming from different apps, and in most cases, the user will be required to perform the authentication only the first time. This happens, for instance, when after authenticating in Gmail, you're automatically authenticated to YouTube, AdSense, Google Analytics, and other Google apps. OpenID providers define a well-known endpoint that apps can use to discover the several other endpoints and features they can use as part of the user authentication flow. We will explore this endpoint in detail in a future lesson. OpenID providers can get certified by the OpenID Foundation via a standard suite of tests and requirements. There are dozens of certified OpenID providers you can choose from today, giving you lots of flexibility to use the one that better suits the needs of your apps. In the next lesson, we will learn about Identity Server, the OpenID Connect provider we will use through this course. In this lesson, we will learn about Identity Server, which is the OpenID provider we will be using across this course. Like I mentioned in the previous lesson, there are dozens of certified OpenID providers you can choose from these days, which can come from organizations mostly focused on providing identity-related services like Auth0 and Okta, to giant software vendors like Google and Microsoft, which offer identity services as part of their cloud offerings. You can certainly choose any of these providers for your microservices architecture, but our choice for this course will be Identity Server, given the unique benefits it provides to .NET-based apps and services. So what exactly is Identity Server? Well, in the words of its creators, Identity Server is an open-source, standards-compliant, and flexible OpenID Connect and OAuth 2 framework for ASP.NET Core. Or in other words, Identity Server is the framework that extends ASP.NET Core to provide OpenID Connect and OAuth 2 features to your services. But why would we use Identity Server instead of any of the other dozens of OpenID providers out there? Well, here for a few reasons. Identity Server was specifically built to leverage and extend the capabilities of ASP.NET Core, like the built-in ASP.NET Identity integration, making it an ideal choice for our .NET-based microservices. You don't need to register or reach out to any cloud service to try out Identity Server, especially for learning purposes. It can run fully in your local box, and you can later containerize it to deploy it to your favorite cloud if needed. There are dozens of ways to customize Identity Server according to your needs, all of them taking advantage of both C# and the ASP.NET configuration system. Not only the project is open source, which by itself is a huge benefit for us developers, but also uses the Apache 2 license, which allows building commercial products on top of it. Plus, it is also part of the .NET Foundation, which brings in all the support from the .NET open source ecosystem. The big .NET community around Identity Server is of invaluable help if you have questions or find any issues as you start adapting it to your scenarios. And like I mentioned before, Identity Server is OpenID certified, which ensures it offers all the features expected of a solid OpenID provider. Let's now take another look at our Identity microservice to understand how Identity Server fits alongside the already implemented components. As you know, we have already taken advantage of the built-in ASP.NET Core Identity functionality to enable the new user registration. We also introduced our Users REST API to enable a few basic user management scenarios. This REST API, in turn, also uses the services provided by ASP.NET Core Identity to simplify how we interact with the user's database collection. We will now integrate Identity Server into this same microservice via the middleware components provided by publicly available NuGet packages, and which will effectively turn our microservice into an authorization server and a non-OpenID provider. This middleware will also be integrated to ASP.NET Core Identity so that it can work with our existing users collection, our upcoming roles collection, and a few other built-in components. With this, our client will be able to send authentication requests to our Identity microservice, upon which the user will be redirected to the sign-in page provided by the ASP.NET Core Identity integration. Then, after successfully authenticating the user, an access token and optionally an ID token will be returned to the client. Finally, the client will be able to use the received access token to talk to our catalog and inventory microservices, and even to the user's REST API in the Identity microservice, which will all now be protected to no longer allow unauthorized access. In the next module, you will learn how to properly secure your microservices in detail by using the multiple security-oriented features provided by ASP.NET Core and Identity Server. In this module, you will learn how to properly secure your microservices in detail by using the multiple security-oriented features provided by ASP.NET Core and Identity Server. By the end of this module, you will have a solid understanding of the following: how to integrate Identity Server into our Identity microservice, effectively turning it into an authorization server and an OpenID provider. How to implement microservices authentication via OpenID Connect. What are JSON Web Tokens and their structure? How to properly secure ASP.NET Core-based microservices. How to generate and use access tokens to reach protected resources. And how to generalize the microservices security configuration to simplify how to add security to future microservices. Let's get started. It's time to turn our Identity microservice into an OAuth 2 authorization server and an OpenID provider. For that, let's start by integrating Identity Server into our microservice. And to do that, the first thing we're going to do is back into our Playwright Identity code base, we're going to add a couple of NuGet packages. So I'll do Ctrl-J to open my terminal, and I'm going to switch into src play.identity.service. And the first package we're going to add is .NET add package duende.identity server, right? Which has the core logic to turn our microservice into an identity server. And then we will also add .NET add package duende.identity server.ASP.NET identity, which provides the integration between Identity Server and the ASP.NET Core Identity Framework. All right, and if you look now at your, I'll close the terminal, at your project file, you should have those two new references right here, as you can see. Okay, so with that in place, what we're going to do now is to add a brand new settings directory. So I'll do that under Player Identity Server service. I'll do new folder and we'll name it just settings. And here we're going to be adding a brand new class to represent the identity server settings that we're going to be configuring in our microservice. So under settings, I just right click and I'll say new file. This is going to be named identity server settings.cs. Copy the name. Let's give it a namespace. So namespace play.identity.service.settings. And here comes the class, public class identity server settings. Let me also collapse this to see better. And so here we're going to define two collections for now. The first one is going to be the collection of API scopes that's going to represent the different levels of access that we're going to be able to grant to any of the clients that want to make use of our microservice. So let's declare public iRead-only collection of type API scope, and let's name it API scopes. Should have a getter and an init. And let's import missing namespaces. Let's do control dot here to import system.collections.generic, and also in API scope to import duende.identityserver.models. And this collection here, for now we're going to just initialize it with an empty array. So it's going to be array.empty of type API scope. All right, let's go down into array here. Let's do control dot and let's import system. Okay, let's try that again. Control dot and let's do using system. It's right there. All right. So that's the first collection. Let's fix this. And the next one is going to be the collection of clients that are going to be authorized to access our microservice. Okay, so this is another collection. It's just to not type too much. I'm going to copy that down here. So this is a collection of client. Okay, and let's name it clients. And then array.empty of client. So now we have this ready. It is time to go into our startup file to properly configure Identity Server during the startup of our microservice. So let me just do Control P to open my my list of files here, and I'm just going to be looking for startup.cs. So I'll select that. Here we are. And the first thing we're going to do is just go down into our configure services method right here. And for now, we're going to instantiate we're going to create an instance of our Identity Server settings class directly here. And later on, we will actually load those settings from configuration. But for now, it's just going to be declared over here. So we're going to say var Identity Server settings equals new Identity Server settings. I'll do control dot, and then let's use play.identity.service.settings. With that in place, now let's head down over here. So just under this section where we have added the default identity services, we're going to be adding another section down here, okay, where we're going to add any of the required services for Identity Server. So here we're going to say services.add identity server, and then we are going to add the two collections that are going to represent both the API scopes and the clients that we're going to configure in Identity Server. So we're going to say add in memory API scopes, and that's going to be Identity Server settings that API scopes. And then in the next line, let's also configure the clients. So add in memory clients and Identity Server settings dot clients. Right? So those are all the services that we need to configure for the Identity Server. And now we have to actually go down into the configure method to also inform the request pipeline that we have to make use of those services, right? And so for that, we're going to go down into just between the use authorization and use routing section right here. That is the place where you have to insert what we would call the identity server middleware, right? And so just make sure that you do it exactly at this point, because if you do it either before or after, before user routing or after user authorization, things are not going to work quite well. So order is very important here. So we'll do app.use identity server. And so with that, we are pretty much ready to go ahead and stand up our identity server. So what we're going to do now is just open our terminal. Okay, let me clean this. And then I'll just do .NET run. And that is going to start our microservice now as an identity server. So since Identity Server is an OpenID provider, it does offer a standard configuration endpoint that we can use to get all the metadata about all the endpoints and configurations that have been enabled for Identity Server. So to check out that information, let's now head down into Postman. Now here in Postman, I'm going to create a new GET request. And this request is going to go against our the host where we're hosting Identity Server. So if you look back at Visual Studio Code, that's going to be in HTTPS localhost 5003. So I'll copy that, paste that here, and then this well-known endpoint lives in this location here. So localhost 5003 dot well-known / OpenID - configuration. Okay, so that's a location where Identity Server will offer all this information. If I just hit send, you are going to get something like this. So this is what we call the discovery document. So, and it is a standard endpoint in identity servers. This discovery document, it can be used by our clients and APIs to download the necessary configuration data. We don't have to go through the entire document here, but a few things to highlight are interesting here. First is the issuer, which is the one that's issuing the access tokens that we're going to be using later. Here's the authorization endpoint that we can use to request authorization codes. Here's the token endpoint that we can use to request an access token. Here's the user info endpoint that you can use to retrieve even more information about the user that you may not have in an ID token. And then a bunch of other endpoints available here. Another interesting piece is the scope support. Remember that the scopes are the different types of access to resources that you can get via this identity server. At this point, it only offers offline access, which means that we can request what we call refresh tokens from this identity server if we wanted to. That allows us to request more tokens without having to authenticate once again once our existing tokens expire. Here are the different types of grants supported so far, which include the authorization code grant that we will be using across this course. But as you can see, there are a few other grants that you could use with Identity Server. As you can see, it does support a response type, the response type that we need, which are code and token, and also ID token, and a few other options there. And also you can see the different code challenge methods that are supported here, including the S256, that is the one that we're going to be using. Okay, so we will see in the next lesson how to start using some of this information in order to request tokens from the Identity Server. But for now, let's see if we can get support for one more scope, the OpenID scope here, so that we can actually use OpenID Connect with our Identity Server. So how can we do that? Let's go back to Visual Studio Code. So now let's go ahead and do Ctrl+C to stop our service. And I'll close the terminal for now. And let's head back into Identity Server settings over here. What we're going to do is we're going to define a brand new collection of what we are going to call identity resources. So these are kind of special resources that actually represent other type of scopes that we want to define for our identity server. So let me go here, and now I'm going to define public iRead only collection of type identity resource. Okay, and this one is just going to be named identity resources. But in this case, we're going to pre-initialize it with one well-defined resource. And to do that, we're going to just do this arrow function. So I'll do new identity resource array. And here I'm just going to define one resource, which is going to be new identity resources that OpenID. Okay, and then let's just close this. Okay, and so this OpenID resource, what it's going to do is actually it's going to spin up an scope of type OpenID, right? So we could potentially just define this OpenID scope directly into the API scopes that we have over here, but you will need to know exactly the name of that API scope, right? So in order to not have to think of that, we will just use the OpenID scope that has already been defined by the server, and that will work just fine. Now, with this in place, just like we did with the other collection, we have to make sure that we also register identity resources back in startup. So let's go back into startup, and let's head up into our configure services method in this block here where we have already added these other collections. So I will go ahead and say add in memory identity resources, and here's where we're going to add identity server settings dot identity resources. All right. Now at this point, it is good to also add one more thing, and that is the integration between Identity Server and the ASP.NET Core Identity Framework, right? That would allow Identity Server to actually make use of our users and profiles that have been configured by the ASP.NET Core Identity Framework. And to do that, that's actually just one more line, which I'm going to just add over here. All you have to do is say add ASP.NET Identity of type application user. Remember, this is the class that we defined and that represents our users in our identity database, right? Application user. So that's the one that we want to be using here. And with that in place, we can go ahead and restart our microservice. I'll do Ctrl J and now say again .NET Run. And now let's head back into Postman to see what else we can find now. And I'll go ahead and refresh our discovery document. I'll just hit send. And notice how now we have one more scope available here, which is OpenID. This means that now our identity server is supporting the OpenID Connect protocol. Also notice that we now have one claim supported, which is a subclaim, which represents the identity, or in our case, the user ID of the user that's requesting access to some resource. Also, if we look back into Visual Studio Code, and I'm going to just stop the server and close terminal for a moment, we should be able to see the key that Identity Server automatically generated to sign our tokens. Remember, those tokens need to be signed by the OpenID provider, and in this case, Identity Server. And for developer scenarios, that key is automatically generated in your box. So if we open our Explorer, I'll do Ctrl-Shift-E right now to open my Explorer. And if we go scroll up a little bit, you're going to see that there's a brand new directory here called keys. And if we open that one, there's going to be a file over here. This one here. I'll try to close this. This one here is the signing key. So this is the key that the server is using to sign every single token that is going to be provided for whoever requests it. In a production-based scenario, you would use actually some sort of certificate that is going to be used to sign this key. So the key is going to look a little bit different. But for developer scenarios, Identity Server automatically generates this key in your box, so you don't have to worry too much about that. Right? And so with this ready, in the next lesson, we will enable our Postman app to verify the identity of the logged-in user via OpenID Connect. Let's enable our Postman app to request tokens from our identity microservice. But before doing that, let's do a couple of things. First, let's get rid of this scaffolding readme txt file, which we don't really need. And the other thing is that we need to register a user so that we will be able to later request tokens for him. So to do that, let's actually start the server quickly. Let's go to src .NET Run. I'll open the browser. I'll go again into our register page, and I'll register a user. Play.com, password. Right? the user is registered now. And the other thing that I'll do is I'll just go back to that register page. And as you can see, the user is now logged in, as you can see on the top here. But I'd like to actually simulate the scenario where the user has never really logged in into the service. So I'll just click on logout so that the user is completely logged out from the application. Then I'll just close this browser. And I'll stop the web server and I'll close the terminal. So in order to register the Postman app to be able to request tokens, the first thing that we have to do is to go to our settings and define a client that represents the Postman app. So we could do that in app settings.json, but in this case, since we are registering what is really a developer tool, and we would not like to have people use Postman to request tokens in production, what I'll do is actually I'll use the app settings.development.json file, which is only meant for development purposes. So here what I'll do is I'll open another section, which we're going to call Identity Server Settings. And this section has to be named exactly with the name that we've been using in the settings file that we created under the settings directory, Identity Server Settings. That's exactly the name that we're going to be using here. And that's because the values for this section are going to be later populated into that class. So close that. And then let's open up the section here. And in this section, we're going to create an array that we're going to be called clients. It's an array. And here we have to define one client. So I'll open this section here. For that client, let's give it a client ID. So client ID. In our case, we're going to name it Postman. Keep in mind again that this is a developer scenario. You probably want to protect this much better, the client ID. But since it's just for development purposes, let's give it the name of Postman. But you could use any other name as you wish. The next thing that we're going to specify here is the allowed grant types, which is an array. And in this one, we also specify what kind of grant we're going to allow for this client, which ties to the authorization code flow we want to enable. And if we go back to Postman for a moment, to our discovery document that you can see right here, because scroll down a little bit, you're going to see the collection of grant types that are supported in our authorization server, in the identity server in this case. For the authorization code flow with Pixie protection, the grant type that we want to use is authorization code. So I'm going to copy that grant type, copy that, back to Visual Studio Code, and that's what we're going to paste right here. It will really depend on what kind of grant types you want to allow for your client, but for our case, that's good enough. The next thing we're going to require here is require client secret, which is a Boolean value. And in this case, since the app that we're using, the client, is a non-confidential client, is a public client, in this case, it's just Postman, the Postman app, we cannot really require a client secret because that app cannot safely store a secret at all. So not for that kind of client. So in that case, we can specify here just false. The next thing we're going to specify here is the redirect URIs, which is an array. And usually what you would put here is the URL in your portal app or in your other web API app where you want to redirect the user after Identity Server has generated that authorization code. However, in this case, the app, again, is just a client app. It's just Postman. And for this kind of installed desktop apps, you can use a well-known value that is going to be the following. So it's just URN, IETF, WG, OAuth, colon 2.0, and then OOB. So again, this is just a well-known standard value that you are going to find on the web that can be used for any kind of installed desktop app like Postman. This is where Identity Server is going to return or redirect the user after the authorization code has been generated. And one more thing we need here is allowed scopes, which again is an array. And if you go back to the discovery document once again, you're going to remember that the scopes that are supported by our identity server right now are just OpenID and offline access. So at this point, since we want to test the ID token, the OpenID Connect flow, and how do we authenticate the user, we're only going to request OpenID for now. So I'm just going to copy this value, OpenID, and I'm going to paste that here. And with this done, this is really all the configuration we need for Identity Server right now. But then we have to do a couple of other things. So like I said, we're going to populate our Identity Server settings class with these values from this section. So now that we have a client, and if we go back to Identity Server settings.cs, now that we have a client, we don't have to initialize this array as an empty array anymore. So what I'll do is I'll remove this right section, and I'll also remove the set here, and I'll turn it into an init, because this array, this collection, should be initialized only once from configuration, and after that, it should not change values at all. Let's now go to our startup file, startup.cs, and then scroll down to the configure services method, and perhaps I'll hide this explorer for a moment. And here we're going to populate the Identity Servers variable from the values from configuration. So to do that, I'll just do the same thing that we do with the other sections. So I'll declare var identity settings equals, and I'll just copy this section over here. And we're going to retrieve the value from configuration for a section named Identity Server Settings, okay, which is this section again, development.json, Identity Server Settings. That's right here. And then we'll deserialize that into an instance, a variable of name of type Identity Server Settings. So that's what we're going to get here. So now when we go all the way down into adding memory clients, Identity Server Settings, that client is going to include that configuration for the client that we have defined over here in application development.json. And then one more thing that we want to do here is to modify this call to add Identity Server right here, just so that it provides a little bit of more verbose information in the console about what's going on behind the scenes. So that way we can tell how Identity Server is operating to some level behind the scenes. So to do that, what we're going to do is just open here, provide a parameter here called options. And then here, we're going to configure this option. So we're going to say options.events.raise success events equals true. So all successful events are logged. And then we're going to do the same 2 times 1 for raise failure events and raise error events. Having these two here, it can be actually very, very helpful when you get in trouble, you don't know what's going on, why Identity Server is not working properly. Just go ahead and enable these two, and you're going to see more verbose messages in the console logs that can help a lot. So with that done, let's open up our terminal, and I'll just clear this, and I'll do .NET run, start the server. Okay, so now it's time to go to Postman. And what we want to do now is to configure Postman to be able to retrieve an ID token from our Identity Server. So how to do that? So what I'll do is I'll open another tab here, and I'll head to the authorization tab here. I'll perhaps minimize this a bit. And in type, what you want to pick is OAuth2. So this is the type of authorization we're going to be using. And that opens a section on the right side where you can input, let's close this, where you can input a bunch of details about the token that you want to request. The first thing that we want to modify here, if you scroll down a bit, is here we're going to switch from authorization code to authorization code with Pixie, because that's the one that we know works best for our type of clients. For callback URL, we want to specify the callback URL that has been registered for our client, for our Postman client. If you go back to Postman, and let's minimize this a bit, we go back to app settings development.json, we remember that that callback URL is this redirect URIs that we have defined here. So I'll copy this back to Postman, and I'll paste that here. Next, we want to use the auth URL. So what would be that auth URL? That auth URL you can actually find if you go back to the other tab where we have the discovery document. The authorization URL is this authorization endpoint that you can find over here. So I'll copy that back here, and I'll paste that here. Okay, remember this is the URL where Identity Server will redirect the user when it can provide, it has that authorization code ready to be provided to the client. Next is the access token URL, which is the URL where the client can go to exchange the authorization code for the access token. That access token URL, if you go back to the discovery document once again, you can find it right here. That will be the token endpoint, this one, which I'll go ahead and copy. And back here, I'll paste it here. Okay, keep going down. The next thing is going to be the client ID. So the client ID is the ID that we use it to register our client in Identity Server. Go back to VS Code. That client ID is right here. And it is Postman. So copy that into Postman and I'll paste that here. And the last thing is going to be the scope. Like I said, the scope represents the amount of access to resources that we want to request from this client. And if we go back to Visual Studio Code, we know that the only allowed scope right now for this client is OpenID. So I'll copy that, OpenID, back to Postman, and I'll paste that here. Okay, so with all that done, we should be able to request tokens. So to do that, I'll just click this Get New Access Token button over here. What that's going to do is open up this login window here. But you may wonder, well, what happened there? Why are we seeing this login screen right now? So let's actually go back to Visual Studio Code for a moment. And let's expand a little bit that terminal. And let's see what happened behind the scenes. So we did .NET Run. So that started Identity Server. You can see the version of Identity Server right there. There's a message here about just using the memory version of persistent grant store. So this means that really all consent decisions, authorization codes, and all these tokens are only going to live in memory during the session. For production, you may want to use another approach where this is stored in a database, but for development purposes, this is all fine. Now let's keep going down. And you can see that after we requested the authorization, the out token, access token, what happened is that the connect authorize endpoint, authorization endpoint was called on Identity Server. And then Identity Server detected that the user is not authenticated, as you can see here. So since it's not authenticated, it decided to go ahead and show the login screen. Now it happens to be that we have configured Identity Server to operate with ASP.NET Core identity. And since that's the case, it was able to show the login screen, default login screen that's enabled by ASP.NET Core identity. So that's how we landed over here. So at this point, what we can do is actually do the login. So I'll say, so player1, play.com, password, and then I'll hit login. Now back in VS Code, in the console, you can see that more things happened. So first, this connect authorize callback endpoint was invoked. So that's the endpoint where the information about the user is being posted back into our authorization server, Identity Server. Then you can see the response from Identity Server right here. It has all the details about this authorization request, the scopes, the grant type, and you can see that the authorization code was generated successfully. Yeah, you cannot see the full value, but this is the authorization code. You can see that it was a success, token issued success, and that went back to the client, and the client immediately tried to exchange that authorization code for a token. And as you can see here, the connect token endpoint was invoked. You can see that the client authentication succeeded. Okay, that call succeeded. And then eventually down here, you can see that Identity Server received the code, the initial authorization code that was provided by Identity Server back to the client. Now it was provided back into Identity Server. You can see the code here. You can also see the code verifier that was provided by the client and other details like client ID and the direct URI. So Identity Server is going to verify all this information. It has to make sure that this is correct. This is what it expects before being able to generate the access token or the tokens. Now we go here, and finally, Identity Server seems happy with what has been provided. It noticed that it was requested an authorization code grant, which means exchange the out code for the access token, and that's exactly what it did. As you can see here, we have an array with two tokens, which is the ID token that represents authentication, and it's right here. It ends with this value, and then the access token that represents authorization to talk to one of the protected resources in one of the microservices. And here's the value, right? The full value is a bit bigger. And so yeah, you can see that it was a token issued success. It was good. And then if that's the case, we can go back to Postman now. And as you can see, we have tokens, which, like we said, which actually it's a bit of gibberish. We're going to explore more about what's behind these values here in the next lesson. But for now, notice that there's an access token and there is an ID token. And so let's focus on the ID token for a moment. And let's actually see what's behind these characters here. So what I'll do is I'll copy all this. And there are websites that you can use to decode what's happening here. So I'll go to one of these websites. I'll go to jwt.ms. So this is one of those websites. Another popular one is jwt.io. So really up to you. They perform a similar purpose. I happen to like this one. So I'll just paste that value that I copied here for the ID token. And you can see the decrypted, well, the decoded version of the token right here. So like I said, next lesson, we will explore exactly what all of this means. But for now, just notice a couple of things like who issued the token, which is our identity server. What is the audience? So, I mean, who is this intended for? In this case, it's Postman. And the other interesting piece would be the subclaim, which means that this is the user ID. This is the ID of our user in the database. So this information here really provides enough info to our client to assert that the user has authenticated, which is the purpose of the ID token. However, there's really not much, not enough information to give something meaningful back to the client, right? So the best that we have right now is the user ID. So what if we wanted to retrieve a little bit of more information? So luckily with OpenID Connect and Identity Server, you can get more information. And let's see how we can do that. So let's go back to Visual Studio Code. And I'll just Control-C to stop the web server, and I'll close the terminal. So let's go back to Identity Server settings. And one thing we can do here is request more scopes, more identity type of scopes. And in OpenID Connect, that other scope that we can use for retrieving more information about the user profile is exactly the profile scope. So I'll do new identity resources.profile. And that brings in a pre-configured scope for additional profile information about the user, assuming that we have that information somewhere in our database. But yeah, with this, Identity Server will support the profile scope. And now we have to go back to app settings.development.json and actually allow that scope in the client. Remember that clients don't just get access to all the scopes. They need to be configured for the scopes that they want to allow. So I'll go ahead and I'll say profile. And that will allow the profile scope for our client. But one more thing that we have to do here is specify another setting, which is called always include user claims in ID token. And for this one, we'll say true. And we need to do this because by default, Identity Server will not return any additional claims in the ID token. And this is because it wants to optimize for the size of that token. It doesn't want to just let the token just grow significantly, because that can have performance effects on the app. So if you enable this setting, then any other available claims related to the user are going to be included in the ID token. So with that done, let's go ahead and start our web server once again. And let's go back to Postman. And I'll go ahead and I'll actually just delete all the tokens. And I'll go ahead and, well, the first thing is we need to request that token. Now the client needs to request this additional token, which is the profile token. So, sorry, the additional scope. So for that, we're going to just put a space between OpenID and profile. So you can keep adding scopes here as long as you separate them by a single space. So now we're ready to request the additional profile scope. And I'll go ahead and click on the Get New Access Token button. And notice that this time we did not get asked to log in again. And that's because the user is already logged in. Postman remembers that we logged in the first time. And so it is already providing the token for us. The token, of course, is valid only for some time, and eventually it will expire, and Postman will not be able to move ahead without us first logging in. So if we keep going down, Here's the ID token once again. So let me copy this ID token, copy that, and let's go back to the JWT.ms. I'll go ahead and paste that here. And as you can see, now we have additional information about the user right here. We can now see the preferred username and the name. And that's because we have that information available in our database. If we had more claims available, those would be showing here. So that's how the client can, that's one of the ways that the client can request additional information about the user. And in this case, just directly in the ID token. Now, if you see, once again, let's go back to Postman. Let's close this and let's go back to our Discovery Document tab. And what we're going to do now is just refresh this. So I'll hit send. And notice that now the Discovery document actually shows more info. So the scope supported has changed and now supports profile as we configured the Identity Server for that. But also, the claims supported have significantly expanded. So initially it was just sub, but now it supports all of these other things, which includes the new claims that we just saw over here. Let's go back here. We saw that we now have preferred username and name, and those are two of the new scopes, preferred username and name over here. Okay, so since Identity Server supports the new claims, those claims were provided to us in the ID token. Like I said, if we had more info about any of these other claims in the database, in our user database, we would be able to show those claims in the ID token. Another way that the client can request additional information about the user, if we don't want to put that information in the ID token, is by using the user info endpoint. So if you call that endpoint with an access token, you will be able to request additional info about the user. Okay, so that's how the authentication can be verified via OpenID Connect and the ID token by the client. Now, we started looking at tokens right now, but we didn't dive in too much into the structure of those tokens. But in the next lesson, we will learn about more about the structure and the use of all these tokens. In this lesson, we will learn about JSON Web Tokens, their structure, and some of the elements that you will usually find in them. A JSON Web Token, also known as a JWT, is a compact URL-safe means of representing claims to be transferred between two parties. This set of claims can be digitally signed to protect their integrity, at which point the JWT payload is part of a structure known as a JSON Web Signature or JWS. JWTs can also be encrypted, but in this course we will focus on signed tokens only. Let's now look at the structure of a JWT. A JWT typically looks like this, which at first glance is just a lot of gibberish. However, there are two periods among all these characters that divide the JWT in three well-known parts. The header, which contains information about the type of token and how it was signed. The payload, which contains all the transmitted claims. And the signature, which is calculated from the encoded header and payload, an added secret, and the hashing algorithm specified in the header. It is used to verify that the message wasn't changed along the way. In the header of a JWT, we will typically find at least these two fields. ALG, which is the algorithm used to sign the token. RS-256, for instance, would mean that the JWT was signed using RSA signature with SHA-256. DYP is the type of token. The type here is usually just JWT, but in the case of OAuth access tokens, the value would be AT plus JWT. The header can also include an optional key ID field, which is an identifier of the key used to sign the token, in the case that the identity provider has more than one key available. Like mentioned before, the JWT payload contains the many claims that are being transmitted via the token. Some are well known and some are more specific to specific identity providers. Here for a few of the ones that you will find across this course. ISS is the issuer, and this is who created and signed the token. For instance, in our case, localhost 5003 is the address of our identity server, authorization server. Auth is the audience, which is who the token is intended for. So for instance, our access tokens are usually going to be intended for either the catalog or the inventory microservice, and our ID tokens will usually be intended for the Postman client. The client ID is the identifier of the OAuth client, which would have been registered initially in the identity server. In our case, that would be Postman. Sub is a very important claim that defines the principal that is the subject of the JOT. So in our case, this will be the ID of the signed-in user in the identity database. If you go to the identity database, you're going to find this ID for one of our users. Scope is the type of access granted to the client. We have seen how to use this already with the OpenID and the profile scopes, but later on we'll see how we can use scopes like catalog read access to grant read access to the catalog microservice, or the inventory full access scope to grant full access to the inventory microservice. AT hash stands for access token hash value, and this one is used to correlate the ID token with the access token in case you need to. AMR stands for Authentication Methods References, and this is an array of strings that identify the used authentication methods. So far, for instance, we have been using PWD, which stands for password. But you could also use MFA for multi-factor authentication, PIN for personal identifier, and many other options that are available for AMR. Then we have a series of values that are really datetime values associated to the token, starting with MBF, which means not valid before, and this is the time before which the JOT must not be accepted for processing. So you cannot use this token before that date. Now these and all the datetime values are defined in seconds since the unit epoch, which is the number of seconds that have elapsed since January 1st, 1970. EXP is the expiration time after which the JOT must not be accepted for processing. IAT identifies the time at which the JOT was issued. Auth time is the time at which the end user last authenticated. IDP is the identity provider name, which in our case will just read as local, because it's a local identity server. SID is the unique identifier of the session of the end user in a particular device or user agent. This could be useful, for instance, when the user signs into multiple devices and the server might want to terminate a particular session. And lastly, we have GTI, which is the unique identifier of the JOT itself. So this could be used to prevent the JOT from being replayed. In the next lesson, we will secure one of our microservices to make sure only clients with a valid access token can get access to it. It's time to start securing our microservices to make sure that only authorized clients can get access to them. Let's start with our catalog microservice. So here I am in a new instance of Visual Studio Code, and I'm going to open the play.catalog code base. So I'll go to play.catalog, and I'll do code.-r to open in the current window. And the first thing that I'd like to do here is to head into the csproc file, this one here. And I'll collapse this for a moment. And you may or may not have these two entries here, these two package references. If you have them, please go ahead and remove them, because that would be obsolete code, depending on when exactly you created this project. If you don't have them, it's fine. You don't have to worry about it. But in any case, we don't need any of these entries. Now, we do need to add a NuGet package here. So I'm going to open the terminal again. I'll switch to src, play.catalog service, and then let's add this NuGet package, .NET add package, Microsoft.ASP.NET core.authentication.jwt better. This is the package that we can use to add the required authentication into our catalog microservice. Okay, so with that in place, let me open up that Explorer view once again. And let's go to our startup file. Okay, I'll close this and I'll close that. Next, let's go down into our configure services method. And here we're going to add an entry to add authentication to this microservice. So what I'll do is I'll open up a space here, and then I'll say services.add authentication. Here we have to specify what kind of authentication we want to enable. So for that, we want to say JWT better defaults. Let's add a missing space. That authentication scheme. So that really just defaults to better. So that's the kind of authentication that we want to use for token-based authentication. And then in the next line, let's do add JWT better. And then we want to specify options here. So options, close this. And then we have to specify two things here. The first one is going to be the authority, which is going to be the authorization server that is the only one authorized to provide the tokens that we're going to receive, the access tokens that we're going to receive. So in this case, that will be our identity server, our identity service. So that would be HTTPS localhost 5003. So yes, I mean, we are hard coding that value right now here, but later on you'll see how we'll do this in a much more configurable way. For now, let's just hard code and we'll fix that later. The other option is going to be what we call the audience. So the audience defines who is the intended user of the tokens that are going to be received here. So we should only accept tokens that are targeted or generated, in this case for the catalog microservice. So for that, we're going to say service settings, that service name. Remember that service name has just name catalog that's coming from an app settings.json file. And so here we are saying we are only accepting tokens for the catalog audience. The next thing that we have to do here is just scroll down a little bit into the configure method. And then we need to enable actually use the middleware for authentication. This is something that many people actually forget. Even I forget it a bunch of times, but you have to do this. Otherwise, even if you register authentication, it was not going to be used in the pipeline and things are just not going to work. So what you want to do is add here app.useAuthentication, and that will enable the authentication middleware. Make sure you do this in this right location, just between use routing and use authorization, so things work properly. Placing it somewhere else, especially outside of use routing or beyond use endpoints, is going to cause trouble. Okay, with that in place, let's go back to our Explorer view, and it's time to touch our controller, our items controller, to specify that we want to use authorization here. So the way that you lock down the controller so that only authorized calls can come in is by using the authorize attribute. So you specify authorize, and we may need to import namespace there. Yep. And if you put this attribute at this level, it means that all the operations that are that live in this controller are now protected by the authorized attribute, meaning that only authorized calls can come in. So if you come without a token, you cannot proceed to any of the operations. There are other ways to enable authorization. For instance, you could go to startup and also set up another way to just say, hey, I want to authorize every single controller. But in this case, since we only have one controller and we only plan to have one in this course, then this should be good enough. And one more thing that we're going to do is in our app settings development.json file. So let's go over there, app settings.development.json. Here we're going to enable a little bit of more logging, specifically for the ASP.NET Core authorization components, just so that we can see a bit more of what's going on behind the scenes. So we will enable Microsoft.ASP.NET Core.authorization. And we'll be using the information level for this one. Okay, and I think we can also close this for now. Okay, so with that in place, let's go ahead and run our identity microservice. I just open the terminal and I'll just do .NET run. And now let's go back to Postman and let's try to retrieve items from the catalog microservice as we have been doing before. So if you remember, we have a bunch of Postman collections that we can use for this. So I'll be using the in the play.catalog service collection. I'll go into items and into the items route. I'll close this. And you remember, this is the route you can use to retrieve items. So I'll go ahead and try to retrieve items from there now. And notice what happens. We are not getting really anything, and now we are getting a 401 unauthorized code, which is expected, right? So this means that the REST API for the catalog items is now protected, and you need to present an access token in order to be able to access the API. If we go back to VS Code very quickly, you're going to see that there's a message at the bottom that says that, yeah, authorization failed. We require an authenticated user, which is exactly what we wanted. So now let's go back to Postman. And since we now know how to get an access token to be able to talk to our microservices, let's get a token and see if we can use that to get authorized into the service. But of course, before doing that, we need to start that identity microservice. So I'll go back to identity now. Here's the identity microservice code base, and I'll just do .NET run in our play identity service folder. Okay, so that starts the service. Back into Postman. And then while being still in the tab for getting items from catalog, I'll switch to the authorization tab. Let's scroll down here. And then I'll go to OAuth to 0. And this will likely be pre-filled with whichever information I used in the previous lesson or the last time. So authorization code with Pixie, our callback URL, out URL, and access token URLs, client ID Postman, code challenge method, SHA-256, and our two scopes, OpenID and profile. So I'll go ahead and get a new access token. So I'll get down, I'll say get new access token. Of course, I'll have to log in. So I'll say play1 at play.com, password, login. So we got a token, proceed. And I think it's a good time to actually take a quick look at how the access token looks like. So let me grab this. In the previous lessons, we took a look at the ID token, while we didn't look at the access token. So let me just grab this quickly into the jwt.ms page, paste that here, and here's how an access token looks like. So as you can see, we talked about many of these properties in the previous lesson. And the things that I'd like to highlight is just a few things, like the issuer, which in this case is the address of our identity microservice, which by the way, we have just configured in the catalog microservice as the only issuer that we can accept. We have the client ID, which is Postman, the sub claim that reflects the ID of our authenticated user, and the other thing is the two scopes that have been authorized for this call. And by the way, if you want to get more details about any of these claims, you can always just go to the claims tab over here, and that will give you a lot of more details about what exactly each of them mean. Okay, so now that we know the details about this token, well, let's use it. So here in Postman, what we can do now is just say use token. So click on use token. The token will now be presented right here in the access token section. And now we can try our query once again by hitting send. And as you can see, we still get an unauthorized response. So that didn't work. In fact, if we go back to catalog microservice, it still complains that authorization failed. So what's going on? Well, the reason for this is both the audience and the scopes that we're using right now as when we're requesting that token. So let me Ctrl-C here. Let's stop that server. We are back in catalog, close this. So remember that when we went into startup.cs in the configure services method, we requested that the audience should be the name of our service, right? Which if we go back to our app.json file, that service name is going to be catalog. So we need that audience. However, if we go back to the decoded version of the token, there's no audience claim at all here, as you can see. So this claim is not good. And not only that, there is no scope that gives access to the catalog or to any of the catalog microservice actions. So we need to fix this. So let's go back to the identity microservice. Here, let's stop this. I'll close terminal. And let's go ahead and open our app.settings.json file. Here we need to define two things. First, we need to define a proper scope that gives us access to operations in the catalog microservice. And we need to define what we call an API resource that contains that scope and that generates an audience for the catalog microservice. So how we do this? Let's collapse this for a moment. And just right here, we're going to open another section. We're going to call it once again Identity Server Settings. I'll open up this. Notice that this section is exactly the same one that we used in AppSettings.development.json a moment ago, as you see. But this time we are defining settings that are going to be working just as well in local development or in production. So we don't need to put them here as we did for the Postman settings. We can just put them in AppSettings.json. Let's collapse this now. And now we're going to define what we call the API scopes. So API scopes, okay, this is going to be an array. And then here we're going to define just one scope with a name. And then you can really use any name here, but it will be great to use a name that's meaningful of what kind of access it grants. At this point, we're going to define a scope that gives us just full access to everything in the catalog microservice. So let's name it catalog.fullAccess. Again, you can use really any name here, just use something that's meaningful for you. So that's the API scope. Now, like I said, we also want to define something that's called an API resource. So API resources. This is another array where, again, we just need one element. And in this API resource, we have to define at least two things, which is the name of the resource and the scopes that it contains. So the name is going to be just catalog, because catalog is the name that the catalog microservice is looking for the audience. Really what happens is that this API resource is going to be transformed, the name of this API resource is going to be transformed into the audience that's going to be placed into the access token. So you have to make sure that you use exactly the right name that catalog microservice is checking for audience. Next, you have to define the scopes. So which scopes are included in this API resource? In our case, that will be the only scope that we just defined over here, catalog full access. So I'll copy that and place it here. So the API resource is connected to the scope that we have defined before. So now, anytime somebody requests the catalog full access scope, it will get an access token with the catalog audience, which grants access to the catalog microservice. The next thing that we have to do is to update our client configuration so that our Postman client can actually request this scope. Because remember, you can't just get all the scopes by default. You have to get access to them. So I'll just copy this. And I'll go back to AppSettings.development.json, scroll down a bit, and in the allowed scopes section for our Postman client, we are going to add this new scope, catalog.fullAccess. And now that we have done this, we do have, back in AppSettings.json, we do have a value both for the API scopes array and for API resources. That means that if we go back to our settings class over here, Identity Server Settings, we don't need to initialize an empty array anymore. So we can remove this empty array. We can set this to init because it should be only initialized once and never modified after that. And we also need another collection here for the API resources. And let's make sure we use the correct type here. So it should be API resource. Okay. So now that we have this new collection, we have to also register it during startup. So let's go back to our Explorer view into startup.cs, scroll down to configure services, and to the section where we configure Identity Server. So here, just after configuring API scopes, we can go ahead and say add in-memory API resources, Identity Server Settings.API resources. So with that, let's go ahead and restart our Identity Server. Let it run. And let's head back to Postman. Before asking for another token, let's actually go back to our tab where we have defined where we have queried our discovery document. Let's go ahead and query that discovery document once again and see what we get. We'll hit send. And if you look here, scroll up a bit more, we'll see that the scopes supported are now including the new catalog.fullAccess scope. So now our authorization server, identity server, actually supports the catalog full access scope. So it is a scope that can be requested now. So let's go back to the items tab here to get items. And now let's scroll down into the section where we define the scopes. Here is where we have to specify that new scope so that we can get it into our token. So I'll say catalog.fullAccess. Okay, so three scopes: OpenID, profile, catalog, full access. And now I'll go ahead and request a new access token. Click that. Proceed. Again, we don't get asked to authenticate again because Postman so far is able to still remember the last time we authenticated. Let's see this new generated token here. I'll copy this, go back to this page, space this new token, and see what we get now. Notice this. Now we have the catalog audience here, which means that we can use this token with the catalog microservice. And the catalog full access scope is also included in this token. So let's go back to Postman and let's say use the token. So we have the token here. Let's make sure we start that catalog microservice first. I'll go ahead and open this, just close that, .NET Run. Back into Postman, and now we can try to actually do a new query with the updated token. So I'll hit send, and this time we do get a 200 OK, and we get the items in the catalog microservice, which at this point is just a potion and the antidote. And if we head back quickly to Postman in catalog, we're going to see that indeed authorization was successful. So it worked because now we have the correct audience and the correct scopes in place in the access token. So yes, so that worked pretty well. And then we still need to enable this authorization for the other microservices, right? Both for the inventory microservice and even for identity for the user REST API. So in the next lesson, we will generalize how we enable authentication in all of our microservices so that it is easier to enable for really any future microservice. Let's see how we can generalize and simplify the authentication configuration for catalog, inventory, and any future microservices. So here I am once again in Visual Studio Code in a new instance of code where we're going to go ahead and get into the play.common code base. And in this shared library, we're going to be adding a new method that any of our future microservices can use to add authentication to them. So let's head into play.common. And then I'll do just code.-r. And here we are in the play.common code base. So the first thing that we're going to need is to add a NuGet package here. So first I'll go into src and into play.common. And then here we're going to be adding that NuGet package that we already added into the catalog microservice. So which is .NET add package Microsoft.ASP.NET Core authentication.jwt better. That will allow us to use the methods required for adding authentication in ASP.NET Core. The next thing we're going to do is go into settings and into our settings class. Let me close this. And here we're going to be adding a property that defines the authority that any of our microservices is going to demand as the only authority that can generate access tokens that they are going to receive. So let's add here prop string authority. And again, this is going to be init. The next thing that we're going to need is somehow of a way to be able to configure the better related authentication options that we have already configured in catalog, but for any microservice. So for instance, if we go back to catalog quickly, if you remember, this is the catalog code base in startup.cs. We defined these options here, as you can remember. So we need a way to be able to define this in a generic way. So that every microservice does not have to do it by themselves. So going back to identity, what we're going to do is to create a brand new directory just under play.common. So new folder, and we're going to call this one identity. And under identity, we're going to create a new class that we're going to name configure JWT better options.cs. Okay, and at this point we can collapse this. So let's define a namespace. It's going to be namespace play.common.identity. And then let's define that class. It's going to be public class configure JWT better options. So this class has to inherit from an interface that is going to provide us with the method that we can use to perform this configuration of options. So that interface is named iConfigure named options. And it needs to you need to provide the type of options that you're going to configure. So that type is going to be JWT better options. Okay, so we're going to add some easy namespaces here, control dot. So using Microsoft extension options, and also Microsoft ASP.NET Core authentication JWT better. Okay, with that in place, let's actually go ahead and implement the interface. So implement interface right here. And the first thing we're going to do here is to define a variable to hold the instance of the configuration object that we're going to be working with. So I'll define private read-only iConfiguration, just iConfiguration, and it's going to be named configuration. Again, control dot, let's add the missing namespace, Microsoft extensions configuration. And then let's define a constructor where we can inject the existing instance of the configuration object. So public configure JWT better options, and we are going to receive an instance of this type. So just copy that right there. And here we'll just capture that variable. So configuration equals configuration. Now that we have that, we can start working on the actual configuration of options. So when configuring JWT better options, the first thing that we want to make sure is that the type of configuration or the name of this configuration matches exactly the one that we've been using for our microservices, which is the JWT better authentication scheme, or just better. To verify that, what we can do is just do a quick check. We'll say if name equals JWT better defaults that authentication scheme, then we will proceed ahead. Remember that the only thing that it has is just better. It's just another way to refer to the better configuration. So next thing is going to be to retrieve the current value of our service settings, where we have defined both the authority and the service name. So we will say service settings equals configuration dot get section. It's going to be name of service settings, like this. Are we missing a namespace? Yep, using play.common.settings, and then get service settings. Okay, perhaps I can go to another line to read better. There. Now that we have that instance, we can start assigning values to the options. If you remember back from catalog, that's what we were doing right here. So let me actually just grab these two lines from catalog, start up in catalog, copy these two, and then I'll go back to identity. Sorry, I'll go back to common, and I'll do something similar. I'll just say options.authority and options.audience. But in this case, we don't need to hard code anymore. Since we have already defined a property for the authority, now we can say service settings.authority. And for the audience, it still is the same thing, right? Just the service name. So that is mostly what we need to do in this case for generalizing what we've been doing so far. But I think it's a good time to do just a little bit more here now that we are making these changes, so that we fix something that's pretty common when we're dealing with claims in ASP.NET Core projects. And it is the fact that by default, some of the claims get renamed to a new name within ASP.NET Core projects. That is just because some legacy behavior that was valid a few years ago, but these days it really doesn't make much sense and actually can make things more complicated. So what we want to make sure is that we do not let that legacy mapping happen anymore, and we become very specific on the name of the claims that we want to use in our service, so that they comply with the current standards as of today. So to do that, we're going to set up two options here. First one is going to be options.mappingBoundClaims. We're going to say false. And the other option is going to be token validation parameters. So it's going to be new token validation parameters. Let's remove this. Add the missing namespace. And here we're going to set two properties. the name claim type, which we want it to be just name, and the role name type, role claim type, which is going to be just role. Okay, so if you don't do this, I mean, things will work just fine. However, you may find issues moving forward as you're trying to integrate with other kinds of identity providers that use more standard claims that you may not be using in your project. So with this, you're getting into the correct standards. The next thing is to define something for this other configure method, where, as you can see, it's very similar to the other one that we just configured, but it just doesn't have a name property, right? So this would be configured when somebody has not defined the authentication scheme that they want to use in their startup. We're not going to really be using this method here. However, it's good to provide some meaningful default. So what we're going to do is just have it call the other method with some default name. So what we're going to say is just configure. And here we're going to say options.default name. And then we pass the options that we received from the parameter. Okay, so that is good to go for this class. And then the next thing that we're going to do is to add a proper extension method that all of our microservices can invoke, and that will also use this configuration over here. So I'm going back to the Explorer. I'm going to right click on identity, and I'm going to add a new file named extensions.cs. Okay, so let's go ahead and collapse this once again. Let's set up a namespace. So it's going to be play.common.identity. And like every extension method, we have to define it as a static class. We'll name it extensions. And the actual method must also be static. So we will define a static method that is going to return an authentication builder instance. Authentication builder. And we're returning this type because this is the one that you usually get as you're configuring your authentication options in ASP.NET Core. So we'll just return that so that if you want, in the caller of this method, you can keep configuring even more authentication options if desired. So then we will say the name for this method is going to be add JWT better authentication. Let's add the missing namespace there. And then we'll say that this is going to extend the iService collection services. Okay, so let's add that other missing namespace for dependency injection. So what we're going to do here is first, we're going to make it so that we register this configure JWT better options that we just created. We're going to register them into this services collection. So we're going to say return services configure options and the type is going to be configure JWT better options. And after that, we're going to do pretty much what we're doing in catalog microservice. So going back to catalog here, remember that we called add authentication and then we called add JWT better. So I'm actually going to copy this from the catalog services, catalog startup file. So copy that back into common, and I'll just paste it here. So add authentication with JWT better defaults right there, adding missing namespace. And then we call all JWT better. However, this time we don't have to specify these options here because we have already specified that it has to use this configure JWT better options class that we defined over here, and that's already taking care of configuring the options. So we go back here. The only thing that we have to do is just get rid of this section, and that's all that we have to do. Notice that when we say add authentication, we specify that it has to be the JWT better authentication scheme, which is just better. And that is what allows our configuration class to jump into this section because it is of the better type. If we didn't use better, then none of this will execute. And so with that done, we're ready to generate our brand new NuGet package. So I'll go ahead and open my terminal. And I'm going to go ahead and generate a NuGet package just like we did the last time. So that's going to be .NET Pack, and then we have to give it a going to give it a version with -p. Package version is going to be 1.0. In this case, it's going to be 3. Last time we made version 2. Now we have to do version 3. You always have to increase the version number. Otherwise, the consumers of the NuGet package will have no idea that there's a new version. They will not pick it up. So just bump it to some other new version. And then the output directory, according to my directory structure, it will have to be // 3 times and then into packages. You can choose whichever other output directory depending on your current location. So I'll hit enter. And the package has been generated. Close this. So just to confirm, we can go back a few directories and then we can go into packages. And indeed, we have the new NuGet package available right here. So this is the package that we're going to start using in all of our microservices. In the next lesson, we will use our updated NuGet package to simplify how we configure authentication in our catalog and inventory microservices. So it's time to go to catalog once again. So let me switch to catalog. And let's start using the updated NuGet package. So I'll just close this. And I'll go to the CS proc. I'll collapse this. So here what I'm going to do is 2 things. The first thing is we need to get rid, well, we don't have to, but we really don't need this NuGet package anymore because it's going to be used implicitly by our play.common NuGet package. So I'll just get rid of this package and then I'll go ahead and bump the version of play.common that we are using. By doing that, this dialog is going to pop up saying, hey, you need to grab a new set of dependencies. We'll say, yeah, that's correct. So let's restore. And that brings in the updated NuGet package with a new method that we created. The next thing that we're going to do is to update our app.status.json file so that it can define the authority properly. So I'll close this. Let's open Explorer, app.status.json. And right here in where we have service name, we have to add the new element that we just configured in our common package, which is the authority. And as we know, authority is just the address of our identity service. If we go back to startup, we can confirm that that authority is right here, which is not going to be hard-coded anymore. Now it's moving into configuration. And now comes the best part, which is the cleanup of startup, because we can use the updated method. So going back to startup, instead of keep doing what we're doing here, we can just add one more line to this series of calls where we're going to say add JWT better authentication. Maybe missing a namespace. Yeah, play.common.identity, our new namespace. And that will replace all these lines, which is the whole point of this exercise. So with that done, let's make sure that this is still working properly. So let's go ahead and start our catalog microservice. I'll do .NET Run. And then I'll go to our identity microservice. And I'll do the same thing, .NET Run. Now I'll go to Postman. And here I'm going to, I am in the tab where we can get all the items for the catalog. And I'm going to request a new token. So the parameters are the same one as in the last time, no changes. I'll just say, hey, get a new access token. It remembered my last login, so it got a token right away. So I'll proceed. Let's explore this token, make sure it is what we expect. I'll paste it here. Update the token. And we can see that we still have the catalog audience and we have the catalog full access scope. So this token should work just fine. I'll say use token, and then I'll go ahead and retrieve items. I'll hit send. And indeed, I can still retrieve my items. Got the potion, got the antidote. Access is being authorized correctly. At this point, our catalog microservice is properly configured for authorization. So it's time to do the same for our inventory microservice. But as a quick exercise, you could try pausing this lesson now and try to enable authorization in the inventory microservice by yourself, following what you have learned so far. You'll see that it's a fairly straightforward procedure. Okay, so what I'll do now is I'll switch to another instance of Visual Studio Code that I have prepared. So this is a new instance. And this time we're going to go into the play.inventory code base. So I'll go into play.inventory code.-r to reuse the current window. And the first thing that I'm going to do is to grab the updated version of our play.common NuGet package. So I'll open play.inventory.service csproc. Right here, I'll just bump play.common from 102 to 103. And I'll say, yes, go ahead and restore the updated NuGet package. Next, I'll go to app.settings.json, and I'll close this one here. And I will add the authority that we're going to need for this microservice. This is going to be exactly the same thing as in catalog. So I'm going to go into the catalog microservice, app.settings.json, and I will grab this one line, the authority, back into inventory, and that sets the authority. Next, I'm going to go into our startup file, and I'll collapse this now. And I'm going to scroll down into our configure services method, where I'm going to keep going through this series of calls for services. And I'm just going to append one more call, which is our new add JWT better authentication. Let's add the missing namespace, play.common.identity. And let's not forget to also add a call to app.useAuthentication in our configure method. We also need to go into our controller and start requesting authorization. So let's open up controllers, items controller. Okay, close that. And here we're going to add the authorize attribute. Authorize, let's add the missing namespace. And like I said before, this makes sure that all the operations in this controller now are going to demand authorization. Otherwise, with no token, none of them can be invoked. And one more thing here in the inventory code base is to bump a little bit the login level of ASP.NET Core so that we can see as things are happening, especially related to authorization. So I'll go ahead and open app.settings.development.json, and we're going to add an entry for Microsoft ASP.NET Core authorization information level. Okay, so that's good enough for our inventory microservice. So I'll go ahead and open our terminal. And perhaps I'll just collapse this, and I'll say src.net run. But as we know by now, this is not enough. We still need to define the proper scope and an API resource in the identity microservice so that it is able to generate tokens that actually grant access to the inventory microservice. So let's go back to identity. Here's the identity code base. I'm going to Ctrl+C to stop the server, close this, and I'm going to go to app.settings.json, collapse this. So remember that for catalog, we did two things. We added catalog full access as an API scope, and we added this catalog API resource. So we're going to do pretty much the same thing for inventory. I'm going to copy this section, and here I'm going to say inventory.fullaccess. And next, over here, I'm going to copy this catalog section or API resources, and I'm just going to add inventory, and we're going to copy the inventory full access scope for inventory. Again, remember that the name that you're going to give to your API resource needs to match exactly the name that you're using for the audience in the inventory microservice in this case. So if you go back to inventory in this case, remember that the audience is always going to be in app.settings.json. It's going to be the service name of the microservice, right? So make sure that these things match. Okay, back to identity. And the one more thing that we have to do is to make sure that our Postman client is able to retrieve this new inventory full access scope. So I'm going to copy this scope here, and I'm going to open app.settings.development.json where we have our Postman configuration, and I'm going to add that new scope right here, inventory.fullaccess. So now the client is able to retrieve tokens that can access both catalog and inventory microservices, as well as they can retrieve the OpenID information. So now we can go ahead and start the server for identity, collapse this, So .NET Run. And let's go ahead and open up Postman. And let's try to do an operation that requires access to inventory. So one thing that we can try to do is to actually assign one item to one of our real users. So the first thing I'd like to do is to retrieve the list of users. So I'm going to go and open our collections. As you remember, we have our Postman collection for identity service here, where we can use the getUsers API to retrieve users. So I'll go ahead and just invoke that. And yeah, we have one user here. Notice that we have not yet protected this API. It did not require any sort of authorization, so we will work on this in the next lesson. But for now, we are able to get the ID of the user, which is what we're looking for. The other thing that we need is some catalog item to assign to the user in inventory. So going back to our getItems operation in catalog, we have our items available here. So now we can go ahead into our inventory Postman collection and into the post operation. Let's collapse this. Here, as you remember, we can go ahead and use the body to specify that we want to grant an item to a user. So the user is going to be this player 1. So I'm going to copy the ID of this player. User ID. There. And then I'll go ahead and get the ID of one of our catalog items. Let's say we want to use the potion in this case. So I'll get the ID of the potion, copy that into catalog item ID. And then let's say I want to grant just one item here. Next, we have to define authorization. So let's go to the authorization tab. Let's pick OAuth 2. And then likely we'll have everything pre-filled here to go ahead and request a token. But we're missing one thing, of course, which is our new scope. The new scope is going to be inventory.fullAccess. And with that, we should be ready to request a new token. So I'll go ahead and request a new access token. Okay, proceed. We got a token. Let's explore this token very briefly. Paste it here. See what we got now. Notice that now we do have two audiences, catalog and inventory, meaning that this token is intended for both the catalog and inventory microservices. And also, we now have the inventory full access scope defined here. So this token should be good to go for use in inventory microservice. So I'll go back to Postman. I'll say use token. I'll go back to the body, and then I'll just go ahead and hit send. We have 200 OK, which means that the item should have been granted to the user's inventory. And to confirm that, we can use the other operation that we can grab from our Postman collection, the get items for inventory. We'll specify our user ID right here so that we can get the items for our one user, player 1. We'll set authorization 2 because we have to specify authorization. We'll make sure we're using the right token, which should be likely the last token in this list. Make sure we have the right scopes, and then we'll hit send. As you can see, 200 OK, and indeed our player 1 has been assigned one item, one potion. So things are working properly. But yeah, like I said, we have not secured yet our users REST API. And we will not be doing this exactly the same way as we just did with catalog and inventory, just because this is an API that lives just next to Identity Server. So for an API that lives within the authorization server, we have to give it a little bit of a special treatment. So in the next lesson, we will learn how to secure the user's REST API with a few of the built-in Identity Server methods. The last REST API that we need to secure is the user's REST API. Since this REST API lives in the identity microservice itself, we will give it a bit of a special treatment, and for that, we will use a special Identity Server API scope and configuration methods, as opposed to the standard ASP.NET Core methods that we use it in the other microservices. So here we are back in the identity microservice codebase. And what we're going to do first is go to app.settings.json, and we need to define a new scope to be able to protect our user's REST API and really any REST API in this identity microservice so that people can get access to it via an access token. So like I said, there's a special API scope that is built into Identity Server that you can use for these cases. So let's open up this, and actually I'll just copy this section, copy that. And the name that you want to use here is Identity Server API. So clients can request this API scope to get access to any of the controllers in the identity microservice. And then, as you might guess, we need to make sure that our Postman client can actually request this scope. So I'm going to copy this, and I'll go to app settings.development.json, and I'm going to add that new scope into the list of the allowed scopes for the Postman client. The next thing that we need to do is to add the authentication middleware in our startup class. So here in startup, we are in configure services. So we're going to scroll down just after our chain of calls for Identity Server. We're going to open up another section over here. We're going to say services that add local API authentication. So this is a method offered by Identity Server to enable authentication in its REST APIs. After doing that, we can go ahead and into the controllers and define that we need to use authorization for the controller actions. So I'll go to users controller, and I'll just collapse this now. And here I'm going to define the authorized attribute. So I'll control dot using Microsoft ASP.NET Core authorization. And not only that, we're going to be using a special policy here to make sure that all the Identity Server requirements are met when somebody tries to use an access token to access these REST APIs. So that policy name is, well, we'll say policy equals local API. Yeah, let's use the missing namespace. That policy name. That's a policy that you can use in order to secure this controller. We'll learn more about policies in a future lesson, but for now, just know that this is the policy that you should be using for securing APIs that live in Identity Server. So with that, we can go ahead and start our server. So I'll open the terminal here, and I'll do .NET run. And now I'll go back to Postman. And here we are back in the tab where we've been querying the user's REST API, right? So if I try to query this again, so I'll hit send, you'll notice that now we get unauthorized, which is expected. So now what we want to do is to use authorization. So I'll go to authorization tab. I'll pick our OAuth 2 type. I'll make this smaller. And the parameters are mostly the same that we've been using, but we need to request one more type of scope, which is our new Identity Server API scope. Okay, so with that, we can go ahead and request a new access token. Proceed. Let's explore this token. Yep. Back here, I'll go ahead and paste it. And as you can see, we have now a new scope available here, the Identity Server API scope. Notice that there's no new audience created here. We still have only catalog and inventory audience. But this happens to be something that's actually optional as you define your API scopes. So you may want to use API scopes in combination with API resources, as we have been doing for catalog and inventory, but you can just use, if you wanted, you can just use scopes and never use an API resource, in which case there's not going to be any audience requested. So that's how Identity Server defined their policy, and that's what's going to work just fine for us. So this token should work. So I'll go back here and I'll say use token, and I'm going to hit send. To expand this, we can see that now we were able to query the REST API just fine. So yeah, all of our microservices are properly secured now, and that will be the end of this module. In the next module, we are going to introduce roles into our identity microservice so that we can use them for doing more advanced authorization across all of our microservices. In this module, you will learn how to use the different authorization options in ASP.NET Core to properly authorize users to your microservices. By the end of this module, you will have a solid understanding of the following: how to store secrets during local development via the .NET Secret Manager. Which are the different authorization types that can be enabled in ASP.NET Core apps? How to seed users and roles in our identity microservice? How to implement role-based security? And how to implement claims-based security. Let's get started. In this lesson, you will learn about the need for authorization checks in your microservices and the different ways ASP.NET Core allows you to perform authorization. So far, we are able to assert who our users are. That is, we can authenticate our users. However, we have not yet defined the permissions our users have across our microservices, which is what authorization is all about. To understand why this is important, let's go through one of our scenarios once again. John would like to add an item to our catalog, let's say a potion, via a web client. Let's assume the web client already acquired an access token after our identity microservice authenticated John. The client then sends a request to create the potion to our catalog microservice, including the access token. Our catalog microservice validates the token presented by our web client and confirms that the token contains the claims that assert that a user authenticated and that user was John. However, Catalog now has more questions about this request. For instance, Catalog should likely only allow modifications to the items collection to admin users. Otherwise, any player could, for instance, modify the prices of any item in the catalog, which is definitely a bad idea. So, is John an admin? Catalog can't tell this yet. Also, assuming Catalog can assert that John is an admin, there's still the question of what kind of permissions the web client was granted on the catalog to start with. For instance, we might be fine with allowing our web client to modify the catalog, but if the client is actually a native client, like a mobile app, we may want to only allow read operations, since we have not performed a proper security review of this app yet. Only after Catalog can answer these additional questions, it might allow the creation of the item in its database. And to do this, we need to enable authorization across our microservices. One way to enable authorization in ASP.NET Core apps is by using roles. Role-based authorization allows limiting access to resources based on the roles the user belongs to. But what is a role? Well, really it is nothing more than a well-known claim that can be associated to a user. Our identity microservice can keep track of the roles associated to each user, and when our other microservices receive this new claim as part of the access token, they can decide what kind of permissions to grant on their own resources based on the role. So, for instance, if the role assigned to our user is player, our inventory microservice might decide to only allow the get operation that retrieves the inventory back of a player, and our identity microservice would only allow getting the current amount of yield associated to the authenticated player. The catalog microservice would not allow any operations to players. On the other hand, if the user's role is an admin, inventory does allow any kind of operation on any user's inventory back. The identity microservice allows any operation on the details of any user, and catalog also allows modifying its collection of items in any way. So, different roles grant different kinds of permissions on each microservice. Another way to verify permissions is via what is known as claims-based authorization. In this model, access to resources can be limited based on any of the claims presented in the access token. ASP.NET Core enables this by allowing you to define policies that group a series of claims requirements that can be verified on any of the operations of the microservice REST API. For instance, our catalog microservice could define a read policy and apply it to all of its get operations. This policy would require that the value of the role claim in the access token must be admin, and the value of the scope claim must include catalog read access or catalog full access. There could be also a write policy where, again, the presented role must be admin, but the scope must be either catalog write access or catalog full access. You could extend these policies to require any specific value on any other claims presented in the access token. As you can see, claims-based authorization allows you to define much more granular and complex rules than role-based authorization. In the next lesson, we will seed users and roles in our identity microservice so we can later use the roles to perform role-based authorization across all of our microservices. Before enabling role-based authentication across our microservices, let's see how we can create or seed a couple of roles, admin and player, and also an admin user the first time our identity microservice boots. So the first thing that I'm going to do is go to our app settings.json file, and we're going to define a new section called Identity Settings, where we're going to put the admin user email. So I'm going to put that section just here under MongoDB settings. I'm going to call it Identity Settings. And for now, this is going to have just one property, which is going to be our admin user email. Okay, and this email could be really anything that you want to use, depending on your scenario. In my case, I'm going to use something very simple like admin@play.com. Now, like we mentioned in a previous lesson, it would not be a good idea to also set the password here, right? Because we don't want to end up checking in this code into a source control repository. So what we're going to do is to actually use the secret manager to define the secret that represents the password for this user, for the admin user. So what I'm going to do is collapse this first, and then I'll bring in our terminal right here. And I am in the play.identity.service directory already. And the first thing that we have to do here is to initialize our project to be able to use secrets. And actually, let me pop up quickly the play identity service csproc file. Yeah, this file here, so that you can see what changes here as we initialize the project. Scroll down a bit. So what I'll do is I'll just type .NET user secrets init, enter. And as you can see, a new entry was added into the project called user secrets ID, which what it does is assigns kind of a unique identifier for the secrets that are associated to this one project. If you go back and look at the secrets.json file that's in your local machine user profile, you will likely find this user identifier over there next to the secrets that we're going to create here. So now we can go ahead and actually create the secret. The secret is going to be named admin user password, and we can create it this way. .NET user secrets set, and then you want to use a name that corresponds to the structure that you have defined, in this case in the app settings.json file. If you go back to app settings.json, we know that our structure starts with identity settings, so we will use that first, identity settings, and then the name of the actual property that holds the secret, which is going to be admin user password. Okay, so that's the name of the property, and then we will set the value. In this case, since it's just for local development, we'll go for something very simple like pass at word1. Very simple. Hit enter. And then the secret has been successfully saved into the secret store. Okay, so I'll close terminal, and with this done, it is time to define an actual class that we can later use to deserialize this configuration, and then we can use it in different places across the application. So I'll open up my Explorer, and I'll open the settings directory, and here I can right-click, new file, and let's name this file identity settings.cs. Copy the class name, there. So here we're going to define the namespace. It's going to be play identity service settings, public class identity settings. And so here we will define both the property that we defined in app settings.json, which is admin user email. I'll copy that. So it's a prop string admin user email. And we'll set it with only an init, as we have been doing with all our settings classes. And the next one would be what we use it for a password. If you remember the password, going back here, the password is admin user password. I'm copying that now. Close terminal. So prop string admin user password. And again, init. The next thing that I'd like to do is to define a very simple class where we're going to declare the strings that represent the names of the roles that we're going to define in our application. We're going to define two roles. One row is going to be the administrator, which can do pretty much anything he wants across all the microservices. And the other one is going to be the player, which is going to have limited functionality in a few places. So for this, what I'm going to do is collapse this, and I'll go to the root, play identity service, right click, new file, and let's just name it roles.cs. Copy the name. So let's define a namespace. Namespace play.identity.service. This is going to be a static class. So public static class roles. And this is static because we only are going to define a bunch of constants here. So nothing special about this class. So we'll define public const string admin equals admin and public const string player equals player. We're defining these very simple strings as constants here because we expect to use them in more than one place across the code base. So just so that we are not repeating strings in a bunch of places, a good practice is just centralize these strings in one place, and then we can reuse them wherever we need them. The next thing that we have to do is to define the logic to create both these two roles and our admin user in our identity microservice database on boot, right? On the first time that the service boots, we want to create all these things so that they are available from there on. And so how can we do that? Probably the best way we can do this initialization is via a hosted service. A hosted service is just a class that you can register on startup and that can execute asynchronous background task logic when the service host is starting. So to create this hosted service, let's first create a directory. So I right click in play.identity.service, new folder. Let's name it hosted services. And in this folder, let's create a new file and let's name our class identity seed hosted service.cs. Copy the class name. Okay, let's collapse this. So let's add the namespace play.identity.service.hosted services. Let's declare the class, public class, identity seed hosted service. So a hosted service needs to implement the iHosted service interface. So let's go ahead and implement that interface. iHosted service. I'll do a control dot and let's do using Microsoft extensions that hosting. And then I'll do a control dot again so that we can do implement interface. So as you can see, a hosted service needs to define two methods. Start async, which is a method that executes when the service host is just starting, and stop async, which is a method that runs when the service host is stopping. And before we can implement this logic, we have to do a few things. First, we're going to need two class level variables, where the first one is what we call a service scope factory. So this service scope factory we're going to use to be able to get access to the service provider object, which in turn will give us access to some of the services that have been registered during startup, like the role manager and the user manager, which we need for this logic of creating roles and users. So let's declare that class. So it's going to be private read-only iService scope factory, service scope factory. And for this, we need to import control dot the Microsoft extensions dependency injection namespace. The other variable that we need is just an instance of the identity settings class that we just declared. So private read-only identity settings. So I'll do control dot here also and play identity settings. Yeah, we have the right things in place. The next thing is to define a constructor for this class. So let's come here. And what I'll do is I'll just do control dot, and I'll say generate constructor, identity seed hosted service. That puts a constructor in place. And then we need to inject the variables that we want to receive in constructor. So that's going to be our services scope factory. That's the first one, and perhaps I'll do it in the next line. And the other thing is an instance of iOptions, which is how you can do dependency injection of configuration options so that you can grab those values from the app settings.json file. So this is going to be iOptions, identity settings, identity options. So let's bring in the Microsoft extension options namespace. And then we can grab those variables. So this dot services scope factory equals services scope factory. This dot actually settings equals identity options dot value. What we also need now, before we can implement start async, is a very simple helper method that we can use to create a role via the role manager in the case that the role does not exist. So let's declare a private method at the bottom. I like to keep private methods at the bottom because they're just implementation details. So private static async task create role if not exists async. Okay, so this is going to receive string the role or the name of the role, and then role manager of type application role manager. Okay, let's import the Microsoft ASP.NET Core identity namespace, and let's import play.identity.service.entities. Okay, so here comes the body. And the body is going to be very straightforward. The first thing that we have to do is check if the role exists. So role exists equals wait role manager dot role exists async role. And if the role exists, then we have nothing else to do here, of course. But if it does not exist, we have to create it. Role exists. So to create a role, what we can do is just say await role manager dot create async new application role, and then we just set the name property, which is going to be the role, and that will go ahead and create the role in the identity microservice database via the role manager. Now this call here will return some result, an identity result that you may want to check to see if there was any exception in there that you may want to handle some way. So I'll keep it a little bit brief here because there's some more code that we need to write here, and to not keep this lesson too long. But you may want to just check the result here for any errors. With that in place, let's go back into our start async method and let's do the proper implementation. So we'll remove this. And the first thing we're going to do is to create an actual scope that we can use to get access to the service provider. So we will just say using var scope equals service scope factory dot create scope. We're using the using keyword here, this using keyword here, so that what comes next happens within the scope of this scope variable. That will make sure that when we are done with what happens after, when we're done with this method, everything that happens inside this start async method is going to be automatically disposed by the .NET runtime. So next, what we want to do is to get a handle of an instance of the role manager and the user manager. So what we're going to do is say var role manager equals scope dot service provider dot get required service of type role manager of type application role. Okay, so that's going to give us the instance of the role manager. Notice how we're using the scope factory to get the scope that then we use to get the service provider, and that we then use to get the actual service for the role manager of type application role, which was registered at some point during startup. We're going to be doing the same thing for our user manager. So var user manager equals scope.service provider that get required service of type user manager of type application user. Okay, so now that we have these two instances, we can start actually creating things. So the first thing we're going to do is to create those two roles that we are going to need. So we're going to say await create role if not exists, and that's going to be roles.admin, and then we'll give the instance of role manager to that method. And of course, let's make sure that this method is an async method so that we can use the await keyword. There it is. And I'll just copy this line to do the same thing for roles.player with the role manager. So that will take care of creating these two roles in our database. The next thing is to create our admin user. So for that, we can use the user manager. So just like we did with the roles, we need to first see if the admin has already been created, or if this is the first time and we are going to create it. So we'll do our admin user equals await user manager dot find by email async, and we will say settings dot admin user email. So we will be using the email to try to find that user in our database via the user manager. And if admin user equals null, that means that it does not exist. And again, if it does exist, there's nothing else to do here. If it does not exist, we need to create it. So in that case, let me scroll down a bit more. So we'll say admin user equals new application user, and we'll set its properties next. Username is going to be settings.admin user email. Remember that by default in ASP.NET Core Identity, the username is just the user email. So that's what we're going to use for the username and for the email. So really the same thing. Admin user email. Yeah, there it is. And with that in place, we're going to go ahead and say await user manager dot create async the admin user, and then we're going to pass the password to this method too. So it's going to be settings dot admin user password. And once again, this method is going to return a result of type identity result that you may want to check to see if the user was actually created or if there was some error in the database, which again, we're not going to do right now to keep the code a little bit brief for this session. And now that we created the user, what we want to do is to add the admin role to this admin user, so which in fact turns this user into an administrator. So we will say await user manager dot add to role async admin user roles.admin. And yeah, that's really all we have to do to have some logic to seed or create both our roles and our user during startup. And one more thing that we have to do here that we should not forget is to provide some implementation for our stop async method right here. And like I said, really we don't have to do much here. This is the method that will execute when the host stops. So the host stops and you get the option to run some sort of logic here. But in our case, it really doesn't make sense. We have to do nothing else. So what we can do is just provide some default implementation for this method. I'm actually going to remove this, and I'm just going to do this. So this points to task.completed task, because really there's nothing for us to implement. So with that done, what we have to do now is to go back into the startup file so that we can both register these identity settings so that they can be injected here. And then we also have to register the entire hosted service so that it can kick in when the host is starting. So let's head back to startup. So I'll go back here into Explorer, startup.cs, collapse this. And here we're going to do two things. First, in configure services, just before doing a default identity, we're going to take advantage of this sequence of calls to also configure our identity settings, because we know that we need to inject those identity settings into our identity seed host service. So what I'm going to do is just say services.configure identity settings, and then I'll add configuration.get section name of identity settings. Okay, so that registers the configuration so that we can later receive that in identity seed host service in the constructor right here. So back in startup, the other thing that we want to do is to register that hosted service. And I think we're going to do that just after the adding the controllers. So I'll add a line here, and then I'll say services dot add hosted service, and it's going to be of type identity seed hosted service, which may need to add the import using play identity service hosted services. There you go. Okay, so with that done, we should be able to go ahead and start the service and see how our database is populated with these new roles and user. So here I am back in the terminal, and I'll just do .NET run. So it's up and running. And what I'll do now is I'll just verify that our roles and our admin user exist in the database. So I'll collapse the terminal for a moment. And what I'd like to do is just go to our MongoDB extension to see our database. So I'm opening up Ctrl+Shift+P to open up this window here, view toggle activity bar visibility. Then we'll go to the three dots over here, and we'll go to MongoDB. I'll expand this. Let's go to the identity database now. And as you can see, we now have a roles collection. We expand it, which has two elements as expected. First one is going to be our admin role. Second one is going to be our player role. So that worked. And then in users, we should have one more user. So the first one is our player one, which we've been using so far. And the next one is our admin user. And that admin user is in fact added to the role that corresponds to the administrator. In the next lesson, we will modify our user registration logic so that we assign every new user to our new player role. Let's modify the logic behind our user registration page to properly assign every new user to the player role, and also to read the user's starting yield from configuration as opposed to keep it hard-coded in the registration page. So let's actually start with that second part first. And what we're going to do is go into our appsetting.json file over here, and we're going to scroll down into the identity settings section. So this one over here. And here what we're going to do is just add one more property to represent that starting yield. So let's just go ahead and say right here, we will do starting yield. And we're going to just go with 100, right? That's a good default to start. With that, as usual, what we're going to do is just to add a corresponding property to our identity settings class so that we can read this value on our C# code. So we're going to go into the settings folder on the left side, and then on identity settings. And here we're going to declare a brand new property, which is going to be prop, and this should be a decimal type. And then the name should map exactly to the name that we have here, starting yield. I'll right click on this, and then I'll go over here. I'll put it right here. And then as usual, this will be an init setter. And now that we have this, we can go into our registration page and actually start making use of this brand new setting. So let's go now up into areas, account, and register cs.html.cs. I'm going to collapse this. And let's scroll down over here where we have defined all of our private fields, right? So what we're going to do is just add one more private field that's going to represent those settings. So it's going to be private read-only identity settings. And then for this, we'll have to do control dot using play.identity.service.settings. Okay, so that imports that. it's going to be called identity settings. All right. And we have to make sure that we inject the instance of those settings in our constructor. So what we want to do is use the options pattern, right, to retrieve that configuration from the runtime, the configuration that was set up in startup, and then extract those identity settings from there. So what we're going to do is just here in the constructor, we're going to do iOptions of type iOptions. I'll do control dot here. So using Microsoft extensions that options. So iOptions of type identity settings, identity options. And now that we have that, let me scroll down a bit. We can just say identity settings, which is our brand new field, equals identity options dot value. And so with that, any value that we have set up here as a starting yield, settings that we have here will be assigned via this value field into our identity settings field. And now we have access to that value that has been set up as part of configuration. And so with that, what we can do is replace the assignment of this initial yield. So if you go scroll up, remember that we've been using this starting yield over here as a constant to populate that in the initial yield. So we're going to just delete that line. It's gone. And of course, that sprinkles an error right here in our onPost async method. And so now we don't have to use that constant anymore. What we can do is just say identity settings dot starting yield. So we are getting that value from configuration. And the second part of this is that we want to assign the user to the player role, like we said, right? So let's just scroll down a little bit more. We're going to go into the if result that succeeded. We know that this line here, so line 126, this is where we create the user. Then if it succeeded, then we're just saying, okay, so user got created. It is at this point that we're going to just add a couple of more lines. And the main thing is going to be to assign the user to the role. So to do that, we're going to be using our user manager. So it's going to be await user manager dot add to role async. And the first parameter is going to be the actual user we're going to add. So that's our user. And the second parameter is the role. And for that, we can do roles, dot player. And just to keep the pattern of this file, we're going to be doing also log information. We can just print a little message here. We're going to say, and we're going to do this, and we'll say user added to the role, and then here we'll put the role. It's going to be roles.player role. All right. And with that, we should be ready to test this brand new logic and see if the user is actually added to the role and has the actual 100 yield that are coming from configuration. But before we try that, what we're going to do is first do a little bit of cleanup in our database, because we want to start creating new users assigned to roles. So the ones that we already have in the database are not going to make sense anymore, right? So we're going to go into our MongoDB extension over here. And as you remember, we have these databases right now. So let's go into the identity database. What we're going to do is we can keep the roles over there, but the users collection we want to delete. Like I said, we want to start brand new. And so for every new user being assigned to the player role. So I'm going to drop the users collection. Okay, I'll just type users. Okay, and remember that this is totally fine. The admin user is going to be recreated as soon as we start the service, and every new user is going to be created by the registration page. The other thing that you want to do also here is in the inventory database, if you have any inventory items over here, remember these inventory items are associating catalog items with your existing users. So if you have anything here, it's going to be kind of inconsistent at this point because you have just deleted the users collection in an identity. So you will have users here that do not exist. So what you want to do is just clean up this one here and start cleaning with this inventory items collection. So I'll just click on drop collection, inventory items, and now it is gone. So with that done, let's go ahead and open up our terminal. And let's go into src, play.identity.service, and I'll do .NET run. So that starts the service. And now we're going to go into our browser over here, and let's go to our user registration page. So that's going to be in HTTPS localhost 5003 identity account register right here. And here we're going to go ahead and add a register user. So this is going to be our player one, play.com. All right, so I'll click on register. Okay, And of course, as usual, we are not expecting to see anything here. We don't have anything at the home, so this is totally expected. But what we want to see is if the user got created and it got assigned to the right role. So I'm going to minimize this. And right away, you can see that we see that message, the one that we added to the code. Notice this. User added to the role, play role. Now, the next thing is going to be to look at our database, right? So I'm just going to right click on the top MongoDB node here. I'll click on refresh. And so let's see, for identity, now we have our users collection back again. We have 2 documents as expected. So I'll click on the first one. Let's see what we get. I'm not going to collapse this terminal for now. So this is our admin user. And he is assigned to some role. So this is role 56BD1. So let's confirm that this is our 56BD1 should be our admin role. Yeah, it is true. It is the admin role. So let's close that and this. And then more interesting, the second user, this should be the player 1 user. All right. And then he is assigned to the role DF7F5. DS7F5 happens to be the player role. Okay, so user assignment to the player role succeeded as part of registration. That's great. And not only that, we are also assigning the GIL, the 100 GIL, to the player user based on the value now from configuration. So this is looking great. And in the next lesson, we will introduce role-based security across our microservices. It's time to enable role-based security across our microservices. Since our catalog of items is something that should be managed only by administrators, let's start by requiring the admin role for all of our catalog REST API operations. So here we are in the catalog code base, and what I'm going to do is go into our items controller in the controllers directory. And here, what I'm going to do first is to declare a constant that defines the name of the admin role. So right here, and let me also collapse this for now, I'm going to declare private const string admin role, and the name of this role is going to be admin. And now that we have defined this constant, we can go up into the authorize attribute, open parentheses, and we can declare that roles equals admin role. Okay, this means that anytime anybody invokes any of our catalog REST API operations, it has to present the role claim, and the value of that claim has to be admin. It's the only way to access our REST APIs from here on. So to see this in action, let's try to make a request to our catalog microservice. So I'll go ahead and do Ctrl-J to open the terminal. And so I'll go into src play.catalog.service, and I'll do .NET run. Okay, so that starts the catalog microservice, and I have already started the identity microservice too. So I'll just head into Postman right here. And here I'll go into the catalog service Postman collection, into the get operation, and I'll collapse this. And I'll go into the authorization tab to make sure that we select OAuth 2. Okay, and then I'm going to make a couple of changes in the parameters I've used here. So the first one is going to be, if you go down into auth URL, this one right here, we're going to make a change so that Postman does not keep remembering the previous tokens that we have requested. And this is because we're going to be switching between admin and player a few times. I want to make sure that we always get prompted to log in every time. So to do that, what you can do is just append the following. So you put a question mark, and then you do prompt equals login. This instructs our identity server that anytime that a token is requested, it has to request authentication once again. It cannot reuse any previous token. Okay, and then if we keep going down where we have defined the scopes, we are going to make it so that we only request the catalog scope. Besides the OpenID and profile scopes, of course, but we don't want to use the scopes of other microservices to make sure that things are working properly for every single microservice. So I'll remove these other two scopes, and we will just stick to catalog full access for now. Okay, so with that in place, I'll go ahead and do get new access token. That opens our screen, and I'll start by logging in as player 1. So player1@play.com. I'll hit login, proceed, and then let's name this player 1. So let's copy this token here, copy the full token to take a look in a moment. Copy, and then I'll just say use token. So now let's click on send and see what we get. And as you can see, we're getting a forbidden result here. So why are we getting forbidden? That's an interesting question. So let's go ahead and decode this token to see what's behind it. So here we are back in jwt.ms, and I'm going to go ahead and copy that token, paste that token, sorry. And then as you can see here are all the claims that are supported by that token. But what you can see is that there is no claim here for the role. So there's no role claim. And without a role claim, our microservice is completely rejecting that REST API call. Because if you remember, back in the catalog item controller, we said that we require the admin role here. And also, in fact, as you can see down here, the logging is clearly telling us that these requirements have not been met. The user that is enrolled must be true for one of the following roles, admin. It's right here. So how can we fix this? Let's go now into our identity microservice actually. Let's go into identity right here, and I'm going to stop it, Control C. What we have to do is to instruct Identity Server to support the role claim for the catalog microservice. So to do that, let's go into app settings.json, and I'm going to close this, and I'm going to collapse that. Let's scroll down into our Identity Server settings section and into our API resources section right here. So in order to request the role claim, what you can do is just add one more property here. So I'll just do comma, and then we will say user claims, and then this is an array. And in this array, we're going to define just one claim, which is role. And that's all it is. So this means that anytime our client gets granted the catalog.full-access scope, the access tokens that it receives will include the role claim for that user that logged in. Okay, so let's see this in action. So I'll do Control J and I'll do .NET run again for identity. And let's head back to Postman. And so I'm going to request yet another claim, sorry, another token. So I'll do get new access token right here. Let's do player1@play.com. I'll do proceed. Let's name this one again player1. And let's copy the access token. Let's copy that. And then I'll go into jwt.ms. I'm going to delete that other token and paste a new one. And as you can see here, now we have the role claim, which has the player value at this point. So with that claim, now we can go back into Postman and say, okay, so let's use this token and let's hit send, see what happens. Now we're still getting 403 forbidden, but this time it is not because we don't have the role claim. We have a role claim, it's just that it doesn't have the value that it expects. And as we know, it expects the admin value for it. So let's try once again getting a new token, but this time let's do it for our admin user. So I'll do admin play.com. Okay, proceed. Let's name this one admin. And let's just say use token. And now I'll hit send. And as expected, it works. We are able to, we get out 200 OK, and we're able to retrieve all the catalog items. So that's how you can use roles to require the proper access into your REST API operations. Now let's do the same for the inventory microservice. So let's go into our inventory code base. And we're going to head into the items controller. I'm going to collapse this. And we're going to define the same constant we defined in the catalog microservice. So it's going to be private const string admin role. It's going to be admin. However, here we're going to do something different. We're going to require more granular access for each of the operations, as opposed to just require that every single operation in the controller needs to be authorized. Every operation will require authorization, but we're going to fine-grain tune each of these operations. So I'm going to actually remove the authorized attribute from this controller. So I'll just remove that. And now I'm going to go down into the, let's start with the post operation. Remember, this is the operation that we use in inventory to grant items to a user. So here, I'm going to go just under our HTTP post attribute. I'm going to add the authorized attribute that I just copied from the top. And I'm going to say that this specific action is going to require roles equals admin role. So now only administrators are able to grant items to our users. Good. So that's good. Now, what is more interesting than this is the get operation. So let's go into our get operation here. So remember that this is the one that is able to retrieve all the inventory back for a specific user. So what we want to do here is a couple of things. So we're going to make it so that only the user that owns the inventory back should be able to retrieve that inventory back. Either that or an administrator. Okay, so if the inventory back belongs to player 1, only player 1 can retrieve the user or an administrator. But if the inventory belongs to player 1 and player 2 comes and tries to retrieve that inventory back, player 2 should not be able to get it because he doesn't have access. How do we implement that? So first, let's make sure that we add the authorized attribute also in the just under HTTP GET to require authorization into this method. Next, what we're going to do is trying to find out what is the current user. How can we find out what is the current user? Well, we can go, let's do it over here. So after we verify that the user ID is not empty, let's do this. We will say var current user ID is going to be, we can use the user class right here, and then we will say find first value. And notice that this method here requires a new namespace, so I'll do a control dot here. You have to import system.security.claims to be able to use this method. And then here, what we want to need is to specify for which claim we want to retrieve the value, right? So this method you can use to retrieve any of the claims that are present in the token that was passed into this method. So if you go back into our decoded token here, remember that we have a bunch of claims, so we could request the value for any of them. But in our case, what we want is the subclaim right here. And this is because this subclaim always includes the user ID. So it matches exactly the user ID that we have defined in the database for this user. So since we want the subclaim, let's just copy that. And back in the inventory, what we could do is just paste that here, and that will get us the value for the subclaim. However, another thing that we can also do here, just to not have to type a hard-coded value like this, is to use the constant that is included in one of the classes of the runtime, of the framework, sorry. So what we can do is just say JWT registered claim names, and I'll do control dot here to import the system.identityModel.tokens.jwt namespace. And now I can do dot sub. And if we hop over sub, you'll see that sub already includes the sub constant right there. So it's a good constant to use for some of the well-known claims. So now that we know what is the current user ID, what we can do is the following. So if, let's go ahead and parse that user ID, because this is going to be a string. Yeah, it's a string. We need to parse it. If this is different than the user ID that we got as a parameter, this one here, okay, it means that the user that's calling this API is not the user that's currently presented by the access token in the subclaim. So let's check if this user is an administrator. So to do that, what we can do is just say if not, let's use the user class again, user.isInRole, and that's going to be the admin role. Okay. So if he is in the admin role, let's let it go in. But if not, then this is completely not a valid user. So we cannot allow him to move forward. So at this point, we have to return the proper return code, and that return code is going to be the forbid response. And forbid, what it means, and let me scroll over here. Yeah, it means that it's going to return our 403, and 403 really means forbidden, which means that the user has been authenticated. However, he doesn't have access to execute this operation. That's the meaning behind forbidden. And that's pretty much what we need to do to enable the expected behavior. So once again, the API will be called with a user ID parameter. And then we will extract the current user ID from the subclaim. So if that the pass-in user ID does not match the current user ID, it means that this is not the same user that has been authenticated in the access token, right? The one pass-in does not match the access token in the subclaim. So then we'll go ahead and check if this user is an admin via this check here. And if it's not, then we'll go ahead and return a 403 forbidden response. Otherwise, we will let the user go in and retrieve the inventory back for the user. And now that we have defined this, of course, we have to go back into Identity microservice and also allow the role claim for the inventory microservice. So let's go back into Identity. Over here, I'll do a Control-C to stop it. I'll close this. And then we're back into application.json. And so I'm just going to copy this user claims section that we just added into catalog. I'm going to add the exact same section into the inventory API resource over here. Right? So now, whenever somebody asks for the inventory.fullAccess scope, the provided access token will include the role claim. So let's go ahead and let's do Ctrl-J, and I'll start my identity microservice. And let's go back to inventory, and I'll do the same. So Ctrl-J, let's go into src, play that inventory.service, and run. So let's go back to Postman. And let's first try to grant items to our player one user by using our administrator. So to do that, let's go back into our collections, into the inventory microservice collection, into post. I'll collapse this for a moment. And then I have already prepared this post operation so that it has a valid user ID, which is for player one, a valid catalog item ID, which is for the potion. And then it will try to grant 3 potions to our player one. Okay, so what we have to configure is authorization. So I'll go back into authorization, and then I'll select OAuth2. And then down here, scrolling down, just like we did for catalog, this time we're going to switch into inventory for the scope. So it's going to be inventory full access. Remember, we are not combining this with all the other scopes, because otherwise we get a token that we don't know if the role claim came from one scope or from the other scope. Right, we want to make sure we use inventory for this case. Okay, and the next thing we're going to do is also go into access token, available tokens, manage tokens. I'm going to delete all the tokens that we have so far. So no more tokens there. So let's go ahead and retrieve a brand new token, get new access token, and this is going to be for our admin user. So admin play.com. Okay, proceed, and this is going to be admin. And I'll say use token. So let's see if we can go ahead. Let's go to body, and let's go ahead and grant these items. I'll hit send, and we indeed got a 200 OK, meaning that the operation was successful. So admin can grant items to users. Now, can the admin also retrieve items for a user? So let's confirm that too. Let's go ahead and open collections again, and let's go to the get operation here. Let's collapse this. And notice that this user here that I have already prepared is the same user that we just granted the items to right here. So what I have to do is once again go into the authorization tab, select OAuth2, and in these available tokens, I'm going to pick the admin token that I just generated. Let's make sure that we have the right scopes here. So yeah, we have the inventory full access scope. So let's try to go ahead and hit send and see what we get. 200 OK, so that worked. And in fact, you can see that we're able to get the inventory back for our player one user. So this is working just fine. Now let's see what happens if we switch to player one, the one that actually owns this inventory back. So I'll go down here into get new access token, and then I'll switch to player one, play.com. Okay, proceed. I'll do player one. And then I'll say use token, and I'm going to hit send. Let's see what happens. Indeed, player one is able to retrieve his own inventory back, which is expected. But of course, the interesting case is going to be what happens if another player, let's say player two, tries to also get access to the inventory back of player one. So to test this, let's go ahead and open our registration page, which I have prepared right here. Okay, remember this comes from the identity microservice, and let's register player two. So I'll do player2, play.com. Okay, and of course this page is expected, but the user has been registered. So I'll minimize this, and now I'll get an access token as player2. So let me go down into get new access token, and I'll say player2 at play.com. Say login, proceed, and this is going to be player2, use token, and then let's see what happens. I'll hit send, and as expected, we are getting a forbidden result. So player2 cannot get the inventory back of player1. Okay, so that takes care of inventory microservice, and the only other microservice that we have to protect via roles is our identity microservice, because remember that we have a user's REST API there. So let's do that. Let's go to identity over here, and let's go ahead and let's do Ctrl+Shift+P to do show explorer. Show the explorer. Let's go into the controllers folder, and let's go into users controller. Let's collapse this again. I'll also do Ctrl+C to stop this and close it. And so, of course, we're going to require that all the operations in this user controller are going to require an admin user. So to do that, we're going to go into the existing authorize attribute here, and we're going to say just comma, and then we'll say roles equals roles.admin. Okay, and then we're going to go back into app.settings.json, and just like we did for the other API resources, we also have to make sure that we include the role claim for the APIs in this microservice. So to do that, what I'm going to do is just let's copy one of these sections, in this case the inventory section, and I'll say comma, I'll add it down here, and this API resource we're going to name identity, and the scope, if you go all the way up here, is going to be the Identity Server API scope, this one right here. So I'll copy that scope, scroll down, and into the identity section here, we will do Identity Server API. Okay, so now anytime somebody requests the Identity Server API scope, the generated token, access token, is going to include the role claim. And that's pretty much it. So let's do, again, Ctrl+J, let's do .NET Run, and then let's head back into Postman. And this time, let's go into the user's REST API. So let's go to Collections, Identity Service. Let's go into Get Users right here. I'll collapse this. And so here in Authorization, let's go ahead and select OAuth 2. And let's scroll down. And let's see what scopes we're requesting here. So once again, let's make sure we only request the scope just for this exercise. We only request the scope for the identity microservice, which in this case is Identity Server API. That's our scope. Let's also delete all the tokens that we generated so far, so do not get confused. So I'll go into Manage Tokens here, delete all tokens. Okay, so to test this, let's go ahead and do Get New Access Token. And let's first try to do this for player 1. Proceed. So this is going to be player 1. So use token, and let's hit send. Let's see what happens. As expected, we're getting a 403 forbidden because this is a player. And if we get a new access token, this time for the administrator, proceed, and this is admin, use token. Now we hit send, and we get a 200 OK, and we can see that we got our list of users down here. So that is working properly. And with that, we have used role-based authorization for all of our microservices. Now, in the next lesson, we go beyond role-based authorization and into claims-based authorization to enable more strict rules on the access to our microservice REST APIs.